Install MLAgents release 13 on my Windows 10 laptop, and I'm just recording it so you can see how to do it too. First thing I have to do is go to download the MLAgents code from GitHub. Let me just do a search for MLAgents download, and that should bring me to the github.com where it's the MLAgents code. And then I'll scroll down to the bottom, and then it has all the different releases. So let me go to release 13 and use that one. I'm going to click download. I'll download it here to this folder, and let me unzip it to a folder of the same name. So I downloaded the MLAgents from GitHub. Now I'm going to use a tool called Anaconda so that I could work with Python on my Windows 10 computer. So let me download Anaconda. And here we have the individual edition, anaconda.com. Let's go here. And if I scroll down to the bottom, it has the installs. So I picked this one, the 64-bit graphical installer, and I run that install. And what I'll have is Anaconda on my system. So now I'm going to start up Anaconda Navigator, and I get this. It starts off on the home, but here I can click on Environments, and I want to create an environment for my MLAgents release 13. So I'll press Create, and I'll give it a name, MLAgents, and I'll just say 13 for release 13. Now I have my MLAgents environment. So I'm going to open up Blender, and I'm going to make a car and a track in Blender. I'm going to make them in the same Blender project so that the scale will match up with each other. So I'll just make a brand new general project and get rid of the camera and the light. Okay, and I could say that this block here is going to be what I'll be using at first to make a car. So let me just name this collection here, car. So the car is a block. Let's get that block more in the shape of a car. So it's not going to be that high, and it's not going to be that wide. So we could say maybe the car has that kind of shape to it, the width and everything, all right? And then we're going to have some wheels on the car. So before I start shaping out the car, I want to put some wheels in there in the place they're going to be. So I'll leave it on object mode, and I'll say add mesh cylinder. Okay, and the cylinder, this little black thing, I'll pop up. I'll reduce the vertices. I don't need that many. And the radius, first let's turn it. Okay, so let's turn it 90 degrees on the y-axis. Bam. See the y-axis here? It's something to note that when I'm working in Blender, let's turn the radius down. The front of the car is going to be this side of the global axis, and the back of the car is going to be the positive y. Working in Blender, if I have my car set up that this is the front, the negative y, and this is the back, the positive y, then when I export it to Unity, everything, the front will be the front. I won't have any problems. So let's make that a little bit smaller for a wheel. And then the depth, let's just bring it in like that. The wheels could stick out somewhat from the car, but not that much. Okay, so now what? Let's position this Flintstone wheel in position for a front wheel. Let me stay with wheel 1. Let me select wheel 1, go to edit mode, and first thing I want to do is cut it in half. So I'm on vertice select. I'll use a loop cut. Let me just put on transparency, and I'll cut that cylinder in half. Then on selection, I will select these vertices and right click, delete those vertices. Then I'll select the ones that they're in the halfway point, and I'll pull them over to the width of a wheel of my car. Okay? I can turn on transparency, go to face mode now, select this face, and use the inset faces to try to outline like a tire. Okay? Then I'll just use the extrude to push in the rim. Okay, so I have a tire and I have a rim. Okay, and that's one wheel on one side. To get the wheel on the other side, I'll just use the mirror modifier. Bam, and it's going to mirror on the z-axis, not the y. Okay, so I have two wheels there. Now let me texture this wheel. So I'll go to UV editing, and I'll view the material mode here. And over here, I'll look at the material properties, and I'll say new material. And for the base color, I'll use an image texture. And I'll open up an image texture that I actually want to use. So I have one on my desktop. It's called NN Palette. And okay, so it loaded up the image here, and it loaded up here in the in this window too. So you see, I just made a palette where it has a bunch of colors. I made an image where it has a bunch of colors and some images. And I'm going to use this for all the objects in the game that I'm going to make. So let me go back on this side here. I'm in edit mode. I have the wheel selected, and I'm press A to select all the faces, and I can see the UV editing for the wheel. So now what I want to do is just take the UV mapping here and try to shrink it down to a size that fits inside a block. So I'll say that the tires are this dark gray there. Okay, you see that's the outside part. Press A again. Now I can select the wheel part, shrink it down to fit within one of the color blocks. So now my whole wheel is black, but I'll just select this face, the rim, and I'll give it a different color. I'll give it the color of like a light blue, like a silver. So now I have the wheel textured and the mirror is textured too. Now I can go back to modeling, and here I could view it also like this with the texturing. And if I go back to object mode, I can apply the mirror. I could always apply my modifiers when I'm in object mode. So now wheel 1, it's the 2 front wheels. Now I'll make a copy of that and paste. And then wheel 2, I'll name it, will be my back wheels. So I just select it like this and move them to somewhere in the back. Okay, so I can view it in texture mode like that. And I realize I also like, say I just have this regular rendering mode. I like it when I do this. I view cavity view, and look how nicely it shades those edges for me. So while I'm working, I'm just going to view it like this. Now I'm going to select the car, the body of the car, and I'll go into edit mode, because now I'm going to start trying to shape the body of the car. So one thing is I want the wheel wells to be around the car. So let me click on X, and I'm going to use loop cuts here. So first, let's see, I'll just put some loop cuts to outline, to box outline each wheel. Okay. I just move my mouse and then I hold down the button and drag. So that's one cut. And another cut I want is the top of the wheel. All right. And then I probably need some cuts here to kind of circle the shape around. I'll show what I mean. So I'll just add like 2 cuts here and one right there in the middle. Okay, now I'll go to vertex mode. Oops, wait, before I do that, I have one more cut I want to make here and here. Okay, now I'm in vertex mode, and I'll be move vertices. What I want to do is let's select all the vertices and try to get this outline, get a nice outline following the shape of the wheel. Okay, so we got that there. Then I'll do the same thing on the back wheels. Oh, another trick I forgot. You see, when I was selecting everything on this side, it's not happening to the other side. But if I kind of cut this in half and work with mirror, then everything I do on one side will happen on the other. So let me just stop a moment and do a loop cut down the middle of this car body. Go to transparency and do the same thing I did when I was doing the wheels. I'll just select this side's vertices and I'll delete them. Okay. And then I'll just add a mirror modifier. So everything I do on one side is also going to happen on the other. There we go. Now I'll continue. Let me just lock on the X. Okay, let's start positioning these vertices. Kind of like the same way I did for the front wheel. I just want to outline the shape of the wheel. Pretty much. So what I'm going to do is to make a wheel well. So I got those 2 wheel wells. Let me add some loop cuts in the middle here. And this middle loop cut section, this is, let me just up that by 2 divisions, and then use a scale tool to kind of scale it out. What I want this to be is basically like the part where the passenger sits in the car. All right, just do that. Move this back a little. It's going to be the part where the passenger sits in the car. And I noticed when I made the loop cuts, it kind of bent around, I guess because I moved that. But I could position these things a little bit straighter if I want to. And I do want to. All right. All right, there we go. All right, now comes the part where I pull out the wheel wells. So I'm going to go to edge select mode, and then let me lock on the X again. I will select, not from the beginning, but from the second edge. I'll go around and select all the edges except for the last one. And I'll do the same thing on the back wheel. I'll select all the edges around the wheel except for the last one. All right, so I have those selected. And now with them selected, I just pull those edges out, and voila, I kind of have like some wheel wells of the car just placed right over the wheels, and the wheels fit right in them. I have a little bit of something happening here where the faces in there are poking out, but I could delete those faces. So let me hide the first wheel and take care of that. So let me select the faces like this. And before I delete the faces, let me just do a little inset. Okay, good. Now these faces here, I'll delete them. Delete faces. And now the car kind of has like a hole. So when I show the wheel there, now it's not crashing into the wheel. Okay. Now I'll do the same thing on the back wheel. Just hide it. First thing, select the faces again. Boom, 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 boom. Do an inset. A little inset here. Needs a little bit more width to it. I don't know. Okay. Oops, I unselected the faces. Now I'll delete these inside faces. There, makes like a hole for the wheel. See, now it's not crashing into the rim. All right. Let's take a look at the car like this. I'm going to make another loop cut right here on the edge. And then from that one, I make one that's just a little bit in from the edge. Now I'm going to go back to face select mode and select this face right here and pull it up. And we start getting a little bit looking like a truck. Okay. But I could also I want to take the face or I want to take the edge. Now I'll just play around moving edges and faces, trying to get a look that I want of like a car's body. All right. And let's see, it's too chunky, right? So no problemo. Just move things around a little. Move this up. And this one over here, let me move this a little bit down. Maybe this one too. What the hell? Let's move these all down, curving down more. And then let's do that. Oops, not that face. Maybe like this. So now I just kind of start moving stuff around, trying to get like a shape I want for the car. I think I could also, just like these edges, just pull them down. Because the front of the car it has to be a little bit more aerodynamic. And then these here could also just pull them down a little bit. So there's no hard rule here. This is all artistic impression until I get something looking more like I want. Now I could make like a spoiler along the bottom of the car. I'm just gonna add a loop cut before I lose the ability to, and I think I did. I'm gonna have a spoiler here. I'll pull it down a little, and I'll put one here, and I'll have one that goes around the back. Okay. Yeah. Now let me just select all those edges that I just added cuts for. Boom, boom, boom. And over here, boom, 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 boom. Okay, I got the edges selected. Now I could pinch them in a little bit, and that kind of makes, see, like a little spoiler fin on the bottom there and there. And then for the side, I could pinch it in on the red, and it makes a spoiler effect there too. But you see what's happening here with this cut? Let me Control Z the pinch on the red. Before I pinch on the red, I want to take the modifier on my car body, and I want to turn on clipping. Now when I pinch on the red, it'll hold that middle part together. Okay, so that's a little bit better. That's more like it. Okay, it's looking a little bit like an off-road vehicle. Let's do the back here. Maybe, whoops, I didn't select everything. Get these. Pull them down. How's that look? I think that these edges here probably could pull them a little bit more in. I mean, so it looks like a car. Maybe I could add a little spoiler on the back, make it look a little bit more racy. So let me just add another loop cut here in the back. take a face, like this one on the edge, and extrude it up. I'm going to show you how I do this, and extrude one more up a little bit. Bam. Really thin. Okay. Then I'll just select this inside face, and I could press E to extrude again, and just go until they meet together. And look, I got like a little spoiler. Whoop-de-doo. Alright, so maybe I want a headlight and tail light. So here in the back, let me do a tail light. So let me just add a loop cut like that there. Okay. Go back to face select and select 1, 2, 3. And let me first do a little bit of an inset. Okay. And the inset over here in the pop-up, I could give it a little bit depth. That's going to be my tail light. Okay, I got my car, and if I turn on the texturing, I had textured the wheels, but I didn't texture the car. So let's go back to, with the car selected in object mode, go to UV editing, then go to edit mode on the car object. It looks like it has a material here already. I just have to change it to use image texture and choose my NN palette image, NN palette 01. Alright, so to color the car, I make sure I have the car selected. I'm in edit mode. And then I press A, it selects all the car faces, of which there are half of them because I'm still in mirror mode. And then let me do, there's two types of mapping here. There's the Smart UV Project, and that tries to create UV coordinates that if I were to like put them over an image, that they would kind of like draw out on the car the way they are here in the picture. So that's Smart UV Projection. And then there's the Light Map Pack. This one works by just trying to take up all the space that's available and taking the faces here to use up the whole space. So since I'm going to do the car with a color and not with some kind of picture or drawing, I'm going to use the light map pack. I'll select all the faces, and then I'll just shrink it down to fit into a color block. One of my color blocks. Okay, and then I could just move the whole thing, and I could make the car a color. All right, like, what's this? Red, dark red. Let's make it like a bright red. No. Let's make it navy or dark navy. I'm just playing around. What's this? Darker navy. Let's make it this navy. All right. So now the car has that navy look, but let me just select the windows. Boom, boom, boom. Boom, boom. And maybe that. Nah, I'll leave that out. How about this? This one? Okay, so let me select what I'm saying are going to be the windows. Now for this one, I'll use Smart UV Project because I'm going to use this area here. So with everything selected, let me scale it down to kind of be prepared to fit in this area here, which to me is kind of like stained glass look to have a look of the windows. And let me just stretch it out to fit the whole thing. Where's that red thing? Right there. Pull it down a little. Right, to fit the whole thing. And then, I get a little bit of shading in the windows just to make it look like windows. That's a big back window. Then I could shade in the lights. So let me select the lights. And again, Smart UV Project, okay. And scale it down to fit in this red tail light picture I have here. Okay. That's my tail lights. And then the same thing with the front lights. Just select the faces. Smart UV project. Scale that down to fit in this white headlamp texture thingy. All right. There. What else? Maybe I want the, what do you call this? Call this like the aerodynamic thing at the bottom. Let's call it the aerodynamic thing at the bottom. I have like the skirt of the car. And I can give that a different color if I wanted to. Let's just drag that down to this. And I guess I can give this the spoiler a different color too. Let's go to transparency mode, look at it from the side. Let me just select the top part there. And give that the same color as the spoiler. Alright, so now I kind of have a car textured out. See, in object mode. I got a car, it's textured out. Then if I wanted to pick different colors for it, I could just always select the car, right? And then I know my car here is this color here. I could just select those UV maps and change the color of the car to something else if I wanted to. Okay? And I'm going to leave it dark. So I made a car. And the car is about the size of 1 cube, right? Now I'll make a track, and I want to make a track that's to the scale that's going to work with this car. Is that car too wide? Nah, whatever. It's a race car. All right, so let's make a track. So to start making a track, I'm going to add a curve. I'm going to choose a Bezier curve. I don't even know how to say that. I'm going to look at this from the top down, and I can see the curve there. Let's scale it up, maybe something bigger like 15. Okay. Now the curve, when I go into edit mode, I could see the control points. If I select the control point's middle point and press the S, then I could control the scale. But when I press the S, let me just press escape, I should be a little further away from it when I press the S. See, so I have a little bit of a line to control. I could tune it down. Have my cursor a little bit away from that point, so I could tune it down. I could also spin it around by selecting one of these and the move tool and move it. That's not a track yet, though. That's just one curve. I could just add more control points. I pick a control point and press E and extrude out another control point. Da-da-da. Let's put this up there. E and extrude another control point. Do-do-do. Try to make things bendy-wendy. E. Then at some point, I guess I'm going to need the track to connect up. So with the track selected, the curve selected, I could say curve toggle cyclic, and it'll close up that gap. And this may be a little bit too hard of a curve, so I could just ease it out a little. There's a wiggle in the track right there. What about this curve? Is it too hard? Just smooth it out a little. So I have a track, and this car is going to go around the track. I think the track still needs to be a little bit larger, so let me just select the whole track and go to scale. And just scale it up so the car has something to drive around that's big enough. So that's the car, this is the track. That's good. Now that I have the curve, let's go back to object mode and let's add a mesh object that I'm going to shape into a segment of a road. Okay, I got 2 objects here. I have them in my car collection. Let's do some organization here. Let's just make another collection here and call it the track. New collection. And I'll just call this the track. Okay. And take the Bezier curve and this cube that's going to be my road segment, put it here in the track. And name this road for road segment. Alright, so I have road selected. And I'll go to edit mode. Did I hide the car from view? I could hide the car from view for now. Alright, so I have the road, right? This cube is going to be the road. Let me flatten it out. Okay, and let me see which way the road's going to be when I turn on the array modifier. Array. Okay, the array goes on the x-axis. All right, so as I put these road segments together, they're going to go on the x-axis. Let's make the road a little bit wider so it could fit like maybe, 1 or 2 cars. And let's make the segment a little bit longer so as it repeats, it has, I'm going to put like some street lamps or some, road lights so we can see motion better. All right, is that flat enough? I can make it flatter. All right, so we need barriers. So let me take the loop cut tool, make that 2 cuts, and then stretch those 2 cuts out to the edge. And then at the very edges, I'll have two little slices there. So I'm going to pick each slice with Control, and then I will use the extrude tool to extrude up a barrier on each side of the road. Okay, about that much. Then I will also do a loop cut like this here. I can make that into 2. And this one I'll squeeze it tighter, 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 until there's about a square. I just want the top face right there, and Shift, and that top face, and then E. Okay, there we go. And I just pull up, oops, I didn't pull it up enough. Pull it up high. All right, so you see as I'm driving down this road, you'll have these street lamps. So that's the pole, then there's the lamp part, and I'll just take each lamp, one on this side and pull it out, and one on this side right here and pull it out. And you can imagine you're driving down the highway, those are the street lamps. Now I'm going to do another loop cut, because on my road, when I go in the blender, I'm going to have like 2 different physics materials. So if you drive down the middle of the road, that's where all the speed is. But if you happen to hit off onto the side of the road, then you know the car's going to go a little bit slower. You get penalized. You hit that part of the road. All right, so now let me add some textures to this. So I'm still in edit mode, face select, and I go to UV editing. All right, so I have my road segment there. So let's make sure we have a material. Road selected, we need a material, say new. And then we're going to use an image texture for the base. Color, an image texture. I got to pick the texture. It's going to be the NN palette that I made. Then let me select these faces here. I'm missing one. Come on, you guys, get selected. There we go. I got them all selected. And, ooh, there's doubles. You know why? Because it's selecting the top and it's selecting the bottom. So let me see. Before I do the UV mapping, let me get rid of faces that are not necessary. So let me just take a moment to go back to modeling here. And I'm going to tell you the faces that I deem unnecessary. One, since it's an array of road segments and this part of the road segment object, they're going to be hidden, I could delete these faces here. Okay, so I select them and I say delete. Then there's also faces on this side. Let me just hide the array modifier and select that, 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 and that, and delete those faces. Okay. Then at the bottom of the road, underneath it, we don't need these faces either, because I'm not going to be seeing underneath my road. So I could just select those faces there. Okay. And I could right click and delete those faces. Now, the thing about the faces on the side is I guess I will see them. If my car is driving down the road like this, I won't see them. But if a camera angle happens to shoot from this side, I don't want the wall to hide the cars. So these things are rendered facing, I could see which side these things are rendered on. I could just use this thing here. Is it here? No. Is it here? Yeah, it's here with this one, the overlays. And down here, there's the normals overlay. And I could have this, and it draws these little blue lines to say which side is the rendered side. So say, for example, the road surface here, it's rendered facing this side. And underneath here, you wouldn't see anything. This side is not rendered. So I'm going to do a trick here. I'm going to have these walls only appear when I'm seeing the rendered side. If my camera in Unity is facing from this side, I don't want this wall to show. So what I could do is I could just select the wall on this side, and I could delete that side of the wall. Oop, here's another wall. Bam, delete that. All right, so it will appear, the wall won't appear when I'm in Unity from this side because there's no blue line pointing here. And I could get rid of this top part too, delete. And then I could kind of make, ooh, did I delete too much stuff? Yeah, I did. Boop, boop, boop. I kind of didn't want to delete this. I want to delete this. I wanted to leave this little bar here because then what I could do is I'll just have this appear. I'll select those two edges and then say bridge edge loop. So I'll always see the headlight poles, bridge edge loop. But I will take away the, go back to face select, I will take away the tops here. Delete that. All right. See how that's like thin now? And now let's do the same thing to this side. Bing, bang, boom. Delete you. And oops, this is also to delete you. And over here, select you, and delete you. And now just bridge the edge loops to have this pole come all the way down to the bottom. So go to edge mode, select that and that, those two edges, and bridge. And then on this side, select this, and bridge. Bam. All right, now back to the texturing. UV editing. And what had I done? I had selected, let me just lock it on the Z there. Why did you get, I'm in edge mode, face mode. Sorry guys, I had to switch to face mode. So I select all those faces, and here you can see the mapping for that. And if I put it over the road, you could actually see the lines. Or maybe I'll use this one. The only thing is the scaling's off, so let me just scale it to fit over the entire picture. And move down a little. And I think that these lines here, let me scale it a little bit better. There we go. The edge of the road and the road. Da-da-da. Cool. So the road's textured. Let me put my array modifier back on so we could see it. There we go. See the road. Now we just need the barriers. Go back to texture mode here. Let me look at it from the side and turn on transparency so I could select the whole barrier and the headlamp thing too. See, all that is all selected all the way through and through. Then here's the mapping. I just need like a light map pack because I'm going to set it all to a color. Control A, shrink it down to the size of a color block. And what color should I make the barriers? I'm going to make them brown. Okay. So I got a road, I got the barriers, the lamps. And now I just have to put the road on the curve. So let's go back to modeling mode. I guess I could turn off those normal projection things. Okay. So I go back to modeling mode. This is my road. I want to cast it onto the curve. So in the modifiers, all I have to do is add another modifier. It's the curve modifier. And then tell it to use the Bezier curve. And I don't see it going on there because I have to put it in object mode. There. Now you can see the curve going on the Bezier curve. It's just not enough pieces. So I just increase the count on the array so that it has enough pieces to go around and finally connect. So in the connect here, you know, there's a little bit of overlap. If I want to, I could leave the overlap, or I could try to play around a little bit to kind of reduce that overlap. So I could pick the Bezier curve, go to edit mode on the Bezier curve, and I could pick one of the transform points. And you could see the overlap here in this texture distortion. First, I think I want to shrink the control modifier here a little bit, S. And then I want to move, oops, okay, I did the S. Now I want to move that control point until I could get that overlap to reduce. Okay, but I don't want to have a crack in the road. I just want to reduce it. So this is pretty good. I got the whole curve, nothing but the curve, blah, blah, blah. So the road's there, but the road's not finished. I want to break it apart into pieces. I want to separate the pieces of it. So I will select the road and go, well, let me make sure I have the road selected. I select the road and I go to edit mode. When it's in edit mode, remember it's not displaying on the curve. And now I'm going to separate pieces off of this. So the sides here, these are going to be what I call gravel. So let me hold shift and select these faces and then separate them. So here it's separate by selection, and that's gone. That's right here, road 001. So let me name that gravel. Then I have the two barriers, right? So I'm going to select this one. I'm going to use transparency mode so I can select all the faces. And I'll separate this, separate by selection, boom. And I'll call that barrier white. Okay, and then I'll select this side and separate the selection and call that barrier yellow. As I was separating those pieces, it kind of looks like they disappeared into nowhere, but it's not that. It's just that when I separated them, those new pieces are not in edit mode, so they went back to the track. See? Because now the road is selected, I could come out of edit mode on the road, go to object mode, and bam, everything's on the track. So it looks like it's all one piece. They perfectly fit together because first I did it and then I separated it afterward. But this is the road. This is the gravel. This is the barrier yellow. See on the inside, it's kind of fading. Ooh, wait a minute. I see barrier yellow got a mistake here. This is still showing. See that little top of the thing? That's a mistake. So the barrier yellow. So where is that coming from? Barrier yellow. So does that mean that's still part of the road? Let's see, barrier white, yellow. I don't need to see the curve. And gravel. Oh, those tops of the headlights. They came out with the gravel. I didn't really want that, but I guess since the car is not going to be hitting those, it doesn't matter. But I had to select a little better. I had to be more careful. All right, so the road, there you go. That's the road. What's the scale like? It's all one. Good. Here was my car collection. Let's view that car again. So does that car look like it could fit on the road? Yeah, it looks like it's scaled about right for the road. The car, I still have a modifier here on the car. So let's take that off. Let's take the modifier off because it's a mirror modifier. I have to get rid of that. But first, the car, the scale is off. It's not 111. So with the car selected in object mode, I could say, what could I say? Object, apply. I said object, apply, scale. Good. So that's now 111. And I could do the same thing with the wheels. They have a scale of that, but their location is off. Object, apply, just apply all the transforms. And wheel 2, object, apply all the transforms. All right, good. So let's take off the modifiers. I'm in object mode. I got the back wheel. What modifier? It has any modifiers on it? No. This wheel? No. But the car does. The car has a mirror modifier. So let's just apply that. Bam. Now that modifier is gone. Why does this have a modifier? Oh, because it had the curve and the array modifier. I'm going to leave those on there because these modifiers, they'll be applied before the thing's exported. But I noticed when I left the modifiers on the car and I exported, then in Unity I had half a car. I don't know why. All right, so I made a car and a track. Now to export it. Well, I'm not finished with the car yet. I want the car to be one object actually for me in Unity. So let me just select all these objects. I select car as the last object, and then I say join. And then the car becomes one object altogether. All right, am I ready now to export? I think so. So now I would export the car as an FBX. I just have the selected object, mesh, apply transform, take off the animation, and I could put it to something like my desktop, and I could just call it car and export car. Then for the track, I could select all the track pieces. There's 4 pieces. And I could do export again, file, export, FBX, see, selected objects, mesh, apply transform, no animation, and I could export the track. Export. So now I have a car and a track I could use. After making a car and the track in Blender, I want to bring it into a Unity project that I'm going to use it in. So here I have a 3D Unity project that I have created, and I want to bring in the cars that I made in Blender. So I'm going to drag the exported FBX file, and I'm going to drop it right here in my scene, in my assets folder, I mean. And it takes a while, but the car is finally going to load up and show its textures. Okay, the textures are showing because when I made the car in Blender, I used this file for a texture, and that file is included in my assets folder too. So with this file here, and with the FBX here and the file in my assets folder, the car gets its textures on it. I want to change something about the texture of the car though. So I'm going to click on the car, and here in the materials, you could see I could specify the materials to use. So what I did is I took this texture and I made a Unity material with that texture. And then being that I made a Unity material with the texture, I could control things like the shininess of it and the metallicness of it. I also could use this optimization technique called enable GPU instancing, which lets the texture load, the material or the texture load into memory once, and from that one memory location be used across all the objects that use that same material. So if I go back to the car now in my assets folder, and on the materials here that I specify that the materials use my NN palette material, and then press apply, the car is now using the NN palette material, okay, instead of the materials that it got from when it was in Blender. Now the car is ready. I could drag and drop it into the scene. All right. The car, I have some here. I kind of did some setup here because, as you can see in this scene, I kind of put some track here, like a block of grass, and then I put these walls. And then for my MLAgent training scenario, I kind of put everything under a parent object. So let me drag the car and put it here in the car's object as a child of the car's object. So if I look at my car in the scene, it's going to need a couple of things. But mainly this is my area scene where I'm going to see if I can get the car to learn how to move forward but not hit the walls. So it just has one goal: move forward. If it's moving forward, that's what I want it to do. Then other than that, don't hit the walls. So the car's in the scene. I wrote a script for that. Before I put the script on the car, I want to show you how do you get the package manager to install the MLAgent package. So I have the MLAgent package installed. Right here you could see it under my packages in the project folder. But if you didn't have that, you're going to have to add it to your project. So you go to Windows, Package Manager. Then up here at the top, when you're in the Package Manager, you could see either all the packages in Unity, or you could just see the packages in your project. So if you want to install the package, you'll have to go to see all the packages that Unity has registered. And then you'll have to scroll down to MLAgents package. This is alphabetical right here. And then you'll click the install button that would show here. Mine shows remove because I already have it. Okay, so I just had to make sure that you had that before you use the script. This script, let me show you the script. Let me open it up. This script, NN area, neural network area script, is a script that I wrote that it's going to help me train the car's brain. It's going to help me train the car's neural network. And it's going to also be able to use a neural network brain from MLAgents to drive the car. So at the top of the script, I need to do some using statement. The using statement, unity.mlagents. And this is where I just mentioned that we have to make sure we got the package from Package Manager for that. Then here I have some require component commands to make sure that when I drag and drop the script on my game object that I have a rigid body. It's going to add one if it's not there, a mesh collider, and a decision requester. So a decision requester, this is a new component. This component is coming from the MLAgents. Now my script, instead of deriving off of the all-common model behavior that Unity always uses, my script, I have to change it to derive off of agent instead of model behavior. I could right-click and say, go to definition when agent is selected, and I could see the methods that are provided by this agent class override. But as you can see here, agent still derives off of model behavior. So I'll still have my model behavior methods, but I'll also have the agent methods in addition. All right, next thing I do is I made a little class within my scripts class. And this class within the class is just to hold the different values that I'm going to use for rewarding and punishing the car. Then over here I have some variables. I have move speed and turn speed. I have the reward info objects instantiation. Then I have to have privately. Private means I'll just see it inside the script. I won't see it in the inspector window. I have privately a rigid body variable. I have the position and rotation variables to store the position and the rotation of a car when the game begins. And I have a bounds variable. And the bounds variable, I'm going to use it later on, so I know just how far down to raycast to see if the car's on the road. All right, so I only have a couple of functions here in the script. These here that start like public override, these here are ones that are overrides from the agent class. Okay, so I'm going to override what the agent class has defined as the initialize function. This is called when the game starts. It's just called one time. So I could think of this initialize function as like the mono behavior start function. So here I initialize my rigid body. I make sure that the drag is 1, the angular drag is 5. I kind of up the drag force because I don't want the car to slide like it's on ice. I'm using physics to move the car. And if the car happens to get tapped on one of the corners, I don't want it to start spinning around like a fan. So I put angular drag there too. Then I just learned from another video that I watched on YouTube that if I set the interpolation on the rigid body to extrapolate, it kind of does a little bit better simulation for what I want to do is, use rigid body force to kind of push an object along another object. Just moves smoother with the extrapolate set. Then I get a reference to the mesh collider and make sure that the convex is true. And I get a reference to the decision requester, and I make sure that the decision period is 1. The decision period is how often the script is going to ask the brain, what do I do? What do I do? What do I do? Then I get a pointer to the bounds. And I also store what the position and the rotation of the car is, the game object is. So in initialize, I just initialize these variables. The rigid body, the mesh collider, and the decision requester, they're going to be there because I have these required components at the top of my script. So that's what initialize does. On episode begin, when I train an MLAgent brain, when I'm using the MLAgent library, the training basically happens in episodes. And every episode has a number of steps of actions that are taken step by step until an episode ends due to I tell it to end and start a new episode, or there's like a maximum count of how many steps in an episode. So when an episode begins, I just kind of want to reset the car. So I make sure it's not moving. I set the velocity to vector 0, and then I make sure that the car is back in its starting position from when the game started. On action received, this is how the car is actually going to be controlled through this method, on action received. A neural network, if I could just bring up a picture of it, so I could describe it. Neural network. Neural network, which is what MLAgents library is all about, neural networks. Neural network, it's kind of modeled after the whole idea about neural networks in computer science is that they're trying to mimic the way brain neurons work in the brain, and they send electrical impulses from one neuron to another. So when you have a computer's neural network, you have these little circles are like the brain neurons, and these connections are neurons connecting to each other. So here on the input side, this is like what a brain observes. This is like the brain, the senses, what the brain could sense about its environment. Like, as a human, you could see, hear, smell, taste, touch, right? So for my car, I'll have some input values of what it could sense. Then there's layers in the middle, layers of neurons in the middle. In this picture, there's only 1 layer. In this picture here, there's 2 layers or 3, but in reality, it's so complex. But these are simple little neural networks. In the middle, these are the layers in the middle, the hidden layers as they call them. This is where all the brain translation of what it sees and what it means to it happen, here in the hidden layers. And this is what the MLAgent library takes care of for us. And this is what we are training the brain to be able to do. We're training these hidden layers to adjust the values that come in here from what it senses, translate them with the hidden layers, and then on the output, there's an action. There's an output value, okay? So that's the structure. So this input layer in the code here in Unity, the input layer is going to be called the observation layer. And the output layer is called the action layer. So here on the action received, the action buffers, these are the output layers of the neural network that I'm getting the information here in these action buffers. And the actions structure, if you look at it, actions dot, you could see it's going to have a continuous actions array and a discrete actions array, amongst other things. And I am going to be using the discrete actions array. Okay, and I'll get back to this in a moment because now I want to throw the script onto the car. So I'm going to select the gray car, and let's drag and drop the script in an area on this car. And we could see a lot of components got added. It added the rigid body because, I had the required component. And here I can make sure the drag is a 1, angular drag is a 5, and I'm using extrapolate. Then it added a mesh collider. And here I can make sure the mesh collider has convex on. It added the decision requester. This is how many times the script is going to ask the brain, what do I do? What do I do? What do I do? And I'm going to turn it down to 1. The lower the number, the more times it asks the brain, what do I do? So the lower the number, the more responsive the car is going to be to its stimulus. And since race cars move fast, I want that to be a low number. Then there's the behavior parameters component. And I would have had this as a component in my require components at the top of the script, except that I couldn't find a type of behavior parameters. And I don't know what that type is. So if somebody knows, tell me in the comments, but I couldn't. But anyway, when I drag and drop the script onto the car, the agent class, it has a require components for behavior parameters and adds it. So the behavior parameters, these are the properties of the neural network brain that's going to be trained or used. So first off is I could have a name for that neural network brain. So since this is the area scene, I'll just call this brain area. The vector observations are the input to the neural network. Okay, remember the picture? These are the inputs. So over here, this has 1, 2, 3 observations in this picture. And over here, I'm going to leave the observations at their default values. I'll tell you why in a moment. And then there's the actions. This is the output of the neural network. So that would be these things. In this picture, there's 2 outputs. For my car, I'm also going to have 2 outputs. One output value is going to tell me how to move, and the other output value is going to tell me how to turn the car. So I could have output values that are whole numbers, discrete, or floats, continuous. I am going to use whole number outputs in my scenario. So I'm going to have 2 outputs, discrete. So I put the number 2 there. So now on each output, it's going to ask me how many values do I want. So on the first output, which I'm going to use for move, what are the different things I could do for move? Let's see, there's only 3 things I could think of. I could move backward, I could not move, and I can move forward. So that's 3 things for move. On the second branch, I'm going to use that for turning. How many things could I do with turning? I could turn left, I could not turn, and I could turn right. So I'm going to set that to 3. And that's how that works. And over here, the model, when I do a training with the MLAgent library, it's going to create a file. That file represents the brain that is trained. It's a ONNX file that gets created. And when I have everything set up nicely here, which we'll do together, and I do the training, the MLAgent library will pop that file right here in this results folder for me. As a matter of fact, the MLAgents folder and the results folder, they get created by the MLAgent library when I do the training. If I don't have a model or brain specified here, then this is definitely going to be in training mode when I press play. But if I do put a ONNX file there and specify one, see I have some here. If I do put an ONNX file there, then the brain is going to control the car, and I can, I could be not in training mode. Then here's my script, finally. Now the script, this max step is put there from the agent class, since I'm deriving off of agent, and that says how many steps per episode. So remember, the training happens in episodes. So if the max step is 0, that means there is no max step. So hopefully in my script somewhere, I tell it to end the episode when something happens, like I hit a wall or something. Then I have my variables, move speed and turn speed. And here I have that class, the reward info class, so I could change the values right here in the inspector window. This reward info class, for it to show here in the inspector window, that's why I had to add system serializable to the reward info class so it could show in the inspector window. All right, so I have everything, almost everything. There's something missing though, the vector observations. I don't have anything feeding the observations to my car yet. So luckily there's a component for that in MLAgents. So since I installed the MLAgent package, if I want to add a component, there's this MLAgents components here, and in it there's ray perception sensor 3D. When I put this on, bam, the ray perception sensor, it shoots out rays from the car, and these rays are detecting what's around the car. I could control that ray perception sensor. I could tell it what to detect. I could specify what I want it to detect by listing here in detectable tags the tags I want it to detect. So I want it to detect, I know I added a car tag to my project, and this car gray, I should tag it as a car, okay? And the car should be on my car perception layer. What else do I want it to detect? These rays, I want them to detect barriers. So I have two kinds of barriers. I have the barrier yellow, and I have the barrier white tag. I have those two tags. What did I just get another one? That's all I got. I got the car, and I got the yellow barriers and the white barriers. You may be wondering, why didn't I just make all the barriers white? That's because, like, say, look at it this way. If the car is moving this way, I just figured, like, when you're driving on a road, in America anyway, when you're driving on a road, to the right of your car, there's a striped line on the road that's color white. And to the left of your car, there's a striped line that's color yellow. So I was thinking if I kind of specify that one side is yellow and one side is white, that will help the car know which way to go. It'll help the car know which way is forward. And here in this area, I guess there is no way forward really, but I just had to pick some yellow and white instead of them, since I got barrier yellow and barrier white. All right, rays per direction. This is what this does. It's how many rays do I shoot out. I'll leave it at 3 per direction. Then the sphere cast radius, that's how big that little ball is for the sphere cast. So I'll leave that by default. Then the ray length, I guess you could have it real short or whatever length you want. I had mine set to 20 by default, so I'll leave it there. Now the ray layer mask, this is where I'm going to say, just check to intercept stuff that's on the car perception layer. So my barriers, they're on the car perception layer, and the car is on the car perception layer, okay? Stacked raycast. All right, this one's important. The car is going to be in motion, and as it's in motion and getting closer to something or further away from something, it's kind of happening over time. So to help get the neural network brain information of things happening over time, I could increase the stacked raycasts. So I'm going to put it up to 8. Then there's the start vertical offset. See, here's where the raycasts start. So I could say if it starts higher or lower. All right, and the same thing, the end vertical offset. Where do the raycasts end? Does the raycast end higher or lower? And I'm leaving it at 0. So that's the ray perception sensor. This ray perception sensor is going to take care of setting the vector observations for me. So that's why I left this a default and I didn't bother changing the numbers. If I'm using the ray perception sensor to feed the inputs, I don't have to set the observation size. Okay, so I have one car here and I have the script. Did I go over the script? Well, I stopped going over the script. So let's go back to the script because I was up to the on actions received. Now, before I go into the script and talk about on actions received, I just want you to see here the actions that there's 2. It's an array of 2, and each position in the array has 3 values. So here in my on actions received method, in my script, I receive an action buffer, and like I showed you, the actions object has a discrete actions array, and that's the one I'm going to pay attention to because here I'm using the discrete. So the discrete actions array at position 0, what is there? What it was set from the brain? What it was set? Is it a 0, a 1, or a 2? What's on the output? So if it's a 0, I don't do anything to the car. I don't apply any force to move it in any direction. If it's a 1, then I move the car backward. If it's a 2, then I move the car forward. Just a note, I'm using add relative force instead of force. Add relative force is relative to the way the car is pointing instead of the scene. Here, the car and the scene, they're pointing the same way. But how about if the car was facing this way? Now look, this is the car's forward. The scene forward still stays the same. So I have to use add relative force to make sure it's related to the car when I move forward or backward. Then I have turning. Turning is what I'm using on the second array position. That's what I'm using on this branch, okay? So at the second array at position 1, because the array start at 0, 0, and 1, I have 3 values, 0, 1, and 2. 0, I don't turn. 1, I turn left, which will be minus my turn speed, and 2, I turn right, which will be the turn speed positive, left and right. Over here, when I did my turn, when I move forward, I use the MLAgent function add reward to tell the brain, I like what you're doing. How much do I like it? However much I say what the reward is. That's how much I like it, what you're doing. And it helps the brain learn to do what I tell it I like, if I give it a positive value. And that's here by default. See, it has my forward is a positive value. And I'm multiplying by the magnitude, to say that the faster the car moves forward, the more I like it. So if the car is moving forward faster and faster, it multiplies the reward and tells the brain, ooh, I like to move faster. I don't want to just move forward, I want to move forward faster. So that's the onActionsReceived function. These values come from the MLAgent brain, right? When I'm using the MLAgent library or when I'm using a trained brain. Is there a way that I can give the actions there? I can with the heuristic function. And I want to use the heuristic function when I'm setting stuff up to make sure that I got the code all set up right. I want to make sure that when I press forward, I could basically set the values myself. So here is, first I set the array positions both to 0. That's my default values. Then I check what I use the input manager get access functions, input.getAccess for the vertical and the horizontal. That's basically, the keyboard keys, WASD, or the arrow keys. And then I get values from -1 to 1 for move and for turn. So if move is negative, I move, well, I don't move. If move is negative, I set the discrete action array at position 0, I set a value of 1. Or if it's positive, I set a value of 2. So I set values here, but these values don't move the car. What happens is I set values here, and then the next time decision requester calls to get an action received, it comes in here, and the array position values will be a 1 or a 2. Okay, so it's a little bit indirect control. What I do here is I'm simulating what the brain output would be, what the brain actions would be by setting it. Same thing with turn. If turn's less, I turn left. I set the value for turning left. If turn's greater, then I set the value to a 2, which will get translated to turning right. So that's this. On collision, enter. So if I hit a barrier, I'll be like punish, punish, punish. Whether I reward or punish, it's the same function. It's add reward. It's just that if it's a punishment, the value's negative. If it's a reward, the value's positive. And what's my value for barrier going to be by default? It's going to be a -0.001. Same thing if I hit a car. I'm going to keep punishing the brain, -0.001, -0.001. And I don't have any commands to end the episode. I just have that there. And what's this is wheels down is just a method I added in to see if the car has the wheels on the road. Okay, so over here I had the bounds object, which I initialized to the mesh renderer bounds. The bounds object actually describes where and how big the car is in the scene. So I cast array down from the center of the car. I cast it down. There's no this transform up, but I could say minus this transform up, and that will be in the down direction of the game object, the car. So from the middle of the car, down from the middle. How far down? The size of the car divided in half, plus a little bit more, plus that 0.05 more, to see if the raycast touches a road. If it doesn't touch a road, it's off the ground. Don't move the car. Yeah, because here in onActionReceived, you can see I said, if the wheels aren't down, return. And if it returns, then the car's not going to move. So that's how I stop the car from moving if it flips over or something. So the script is kind of small. It's the MLAgent brain that's going to be doing all the work, really. So now I come over here. I want to test to make sure that the controls work. So I'm going to press play, and I'm going to try to move the car with the keyboard first. And it didn't run. I have an error. It says tag barrier is not defined. Tag barrier white is not defined. Really? I must have spelled something wrong, huh? Let's look at the properties on the ray perception sensor where I specified tag names. Oh, I spelled barrier white with 3 R's. So that's a misspelling. Okay. And then the other thing says tag barrier is not defined. So somewhere I got barrier being used. But where? Where do I have that? Well, here it says nnarea.cs line 109. So 109, barrier. Ooh, yes. Old script, didn't update it. Barrier white is true, then add that. Or collision.gameObject.compareTag barrier yellow equals true. Then do the reward. Okay, so did I spell everything right? No, look at that. I stuck a U in there. Okay, barrier white and barrier yellow. Okay. Thank you, debugger. Compile those scripts again for me. Okay. Now let's press, ooh, let me make sure my camera is set to see this view. Main camera, Control-Shift-F. Now I press play, and I see if I can move the car with the forward, the backward key, turn left, and I turn right. How about if I hit the walls? Boom. 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 So I'm just testing the movement of the car. Okay. So it works. I'm controlling with the keyboard. Now I guess I want to press stop. I want to make sure that this car is going to get controlled by the MLAgent brain. I want to train the car now. All right. So to do the training, let's just organize here a little bit. I don't have anything to end the episodes, so I'm going to end the episodes here with max step. And how many steps should I do per episode? I don't know. Let's just say 1,000. Maybe that's too many. I don't know. Say 1,000. It'll take a while. And then 1, 2, 3. Maybe I'll say 500. Okay. Then I have to start up the MLAgent library. So the MLAgent library, that's another install. That's a Python library. So I had to get the code from GitHub for the MLAgent library. And then I had to install it on my laptop. I used Anaconda. It's like an IDE for working with Python. So with Anaconda, I created an MLAgent environment from the Python code from GitHub. And now I could go over here and start up the Anaconda prompt. It starts in the base environment. I could start up the MLAgent environment by typing conda activate. And my environment, I named it MLAgents 16. Enter. Now it's running the MLAgent 16 environment, but the path is not what I would like. So I'm going to go into Unity and use the Show and Explorer to get the path of my assets folder. And here in my MLAgent library thing, I will say CD for change directory, space, Control V to paste in the path and press enter. Now I'm running the MLAgent library, and the current path is the path of my Unity assets folder. Now I could type the command to start up my MLAgents library. MLAgents learn, and I always use the option force to make sure it overwrites whatever brain's there and starts a new one. I should see the Unity logo, that's good. And then I should see the instructions telling me to press start in Unity. It listens on port 5004. That's how the MLAgent library talks to Unity. So now I could go back to Unity and I could press play. And that movement is not me with the keyboard. That movement is the MLAgent library having the actions that come out of the neural network getting translated into actions for the car. And I think steps of 500 is too short because you see how it keeps resetting? It doesn't even get to a wall. So I'm going to have to make the steps a little bit longer. So I'm going to press, I could stop the training. I could just press stop in Unity. And then here in the MLAgent library, it actually stops and comes back to the command prompt too. All right, so the car with steps of 500 is way too short. So I'm going to make it 5,000 steps. And I'm also going to make more cars because how is my car going to detect if it could collide with another car if there's only one car? Plus, the more cars I have in here that are set to train the same brain name, the faster the training could happen because it's kind of multiplying the number of experiences that could be felt by the cars. Just a little bit of randomness there. So how many cars I have? 11. They all are clones. But all these cars, they're going to train the same brain because right here, behavior name is the same behavior name. So I make sure everything's in training mode. I make sure my script has the max steps because my script requires something like this since I don't have an end episode command in it. And I make sure that the model is none. I go back to the MLAgent library, MLAgents, learn, force, enter. And when I see this, I'm ready. Go back to Unity and press play. And I can put this window here, just the bottom, to show the progress. Basically, when the training started, it lists some commands about what it's doing. But here, it actually shows what the hyperparameters are for the brain, for the neural network brain. A value of interest here is the max steps, which is 500,000. So this training is only going to go up to 500,000 steps, and then it's going to stop. Like a lot of times, you know, training neural networks, it takes millions and millions and millions of steps for more complex things. But this one's going to stop at 5,000, and we'll see how good the cars get at driving. So we can just watch this here. As the training goes on, there'll be some little lines output here to see what the mean reward is. So if the mean reward is like totally negative, then the cars are receiving a lot of punishments and no rewards. And it should start off pretty negative until it gets to a positive value. And then as the training and the learning happen better and better, I expect that the report over here is going to show a more positive value. All right, so training completed. Let's look at the reward values. Ooh, they really went up. I'm very hopeful for how well these cars are going to drive around this area. So let's go ahead and try to use the brain on those cars and see how it worked. So let me focus on Unity, make sure I select the cars. I could turn off max step. And here I could set the car to the area brain. See, so the behavior parameter is area, and area brain would be the brain that just got created. So those are the two things I need to do to switch it to use the brain to drive the cars. And now I'll press play and see how the cars perform. How well did they train? What are they going to do, actually? Sometimes you let a training happen and something you don't even expect happens. You're like, wow, how did the car figure out how to do that? Oh, pretty cool. So they kind of try to swirl around. They're driving themselves. Cool. Okay, here I have a scene where I'm going to try to get the cars to move forward and control their movement to a goal. The goal would be to hit this green bar and not the red bar. And this is like the kind of like a second step after I had them drive around in an area with no goal of anywhere to hit. So I did the same thing here with these barriers, the yellow and the white, with that idea that when you're driving on a road, at least in the United States, when you're driving on the road, the yellow line on the road is to the left of you and the white line on the road is to the right of you. And I figured if I do give that kind of information to the car, that would help it know which way is forward. See, so some of these cars, I'm going to have them pointing the wrong way. And let me just go over here what I have. Yeah, so there's the walls there. And everything I want the car to see, I put on the car perception layer. And I tag this, the barrier yellow. This one's barrier white. Then there's the win bar, I tagged it as win. And the lose bar, I tagged it as lose. And then I have my cars. Okay, so on my cars, I had put my script on there for NN forward. I just took a copy of the area script and I made a forward script in case I have to make any changes, which I do because here on the cars that can move forward, I have two new reward things, one for hitting win and one for hitting lose. Otherwise, everything else is the same. So my cars I tag as car, and they're on the car perception layer. All right, so what else do we have on the car? We have a rigid body, that's what we're using to move it. I set the drag values and the interpolate value. We have the mesh collider, which is convex. We have the decision requester, which requests decisions from the neural network brain. I have it set to a 1. And the behavior parameters, this is the parameters for the neural network brain that we're going to create. This is the name of the brain, forward 1. For the observations, we just left it at 1. We don't have any observations that I'm manually adding. I'm just going to be using the ray perception sensor. And then for the actions, I'm using whole number values on the actions, the output of the neural network brain. There's 2 of them. And each of those are going to have 3 different available values, 0, 1, and 2. And then here on the script, the max steps is set to 0 because inside the script I have some end episode commands when I hit the walls. Then these are the rewards that are being set. And first off, it starts with the defaults that we had from area, where I just had 0.001 for everything. negative or positive. And then with the win and the lose, since the win is out here and there's going to be rewards happening with the car moving forward, I want to make sure that there's an overpowering reward when it hits the win wall. Okay, and I have my little do episodes variable to say whether to do an episode, end the episode when I hit a wall. Then finally, all these little rays coming out of the cars, that's the ray perception sensor. So, wait a minute. A little bug here. I got barrier yellow in there twice. It only needs to be in there once. Okay. So on the ray perception sensor, it's going to detect cars, the barriers, and the win-lose bars. It detects things on the car perception layer, and I have raycasts stacked, so I get a sense of history of motion. Helps the brain figure out movement a little better. So those are my cars. Now I just want to start up the MLAgent library and do a training with these cars. Before I do that, though, I could test to see if take a look at the script real fast. All right, so here I have a quick look at the script. The script is going to derive off an agent class, so I have a using statements for the MLAgents package, which I installed on the project. I have my 3 required components that I could add. So here's my reward structure. Here's the instantiation of the reward structure. Here's my move and turn speed, my do episodes flag, some private member variables. On initialize, I set my private member variable values, like make sure that the rigid body has those values, the mesh collider is convex, the decision request is a 1. Then I get a bounds object, so I could do the checking to see if the wheels are facing the ground or not, and the recall position rotation. Training happens in episodes, so here I have my on episode begin where I reset the car and the car's position and rotation and make sure it's not moving. And then on action received, on the later versions of the MLAgent package manager, they changed it to use action buffers, and inside that is the action buffers is just this. If I take a look at actions dot, you can see it just has in it the continuous actions or the discrete actions array. They're both in there. I just use whichever one I want. And the one I'm using is the discrete actions, because you remember here with the cars, I used in the behavior parameters, I'm using the discrete branch. Okay. Is wheels down? That's a little method I wrote. You can see it down at the bottom. That checks to see if the wheels are facing the road or not. Magnitude, that's how fast the car is moving. And I use square magnitude instead of magnitude, because magnitude takes a little longer to calculate, and all that really matters is the faster it's going that I have a bigger number. So in the discrete actions array at position 0, right, position 0, branch 0, that's my the numbers I'm going to use for movement. So if it's 0, 1, or 2, I don't move, I move back or I move forward, and I just have a little extra thing here. If it moves forward, I like it, so I'm going to add a reward. It's a reward because the value is positive, okay? And then over here, the discrete actions array at position 1, that's the position in the array that I'm going to use the values to determine how I'm going to turn. So 0, 1, or 2, don't turn, turn left or turn right. Heuristic is a chance that I have to control the car by setting the values in the action buffer that on action receive is going to read. So here first I can set them to 0, and then I could move and turn. I get those values from the input manager of Unity. I just read the vertical and horizontal axis. And if move is less than 0, I turn, I go backwards. If it's greater than 0, I go forward on array position 0. And then at array position 1, same thing, less than 0, I put a 1 there, and greater than 0, I put a 2. So here in the heuristic, I put values in the discrete actions array because those values will get translated in the on action received. Just remember that. And then here, this is where I'm going to get my other rewards from when I interact with the scene. So it's the on collision enter. If the car hits a barrier, then I do a reward for barrier, but I don't reset the episode. Then if I hit a car, same thing, I add the reward for a car, which is a punishment, and I don't reset the episode. But the goal is to hit the win. So if I hit the win, I add the reward and I end the episode. And if I hit the lose, the opposite. And the last method here is the one that I wrote just to tell if the car is with the wheels touching the ground or the wheels facing the ground. So it's like I cast a ray from the center of the car down. So this dot transform is transformed with respect to this, the game object. And there's only a dot up. There's no dot down, so I had to say minus. And then how far down do I cast a ray? Just about where the wheels end, just about to the bottom of the car. And that's why I needed the bound size y. All right, so say if the car is size y of 1, then this would go like a little bit more than halfway down, so it could reach the wheels, right? So if you look at a car and you say, all right, this car, it's just going to cast the ray down to about here. Okay, this car's not on the ground. It shouldn't move. Or if the car's rotated around and the wheels are facing this way, like something like this, then, you know, this car shouldn't move because the thing's not flat on the ground. It's not on the ground. So it's just a way to make sure that the car is ready to drive. Otherwise, the car is like a rocket ship. All right, so that's the script. Now I can start a training. So to start a training, like I said, I had to have the MLAgents package installed so I could even write the script that derives off of agent. And I had to have the MLAgents library installed on my system, which that was like the first part of the tutorial. Okay, so now let's start up MLAgent library. So I have a tool, Anaconda, that I installed to run the Python environments. I start the Anaconda prompt. I start up the MLAgent environment. I say conda activate MLAgents 16, and I type MLAgents 16 because when I made the environment, that's the name I gave it. I could have called it my MLAgent, and that would be the name, but I called it MLAgent 16. So now I'm in that environment. Now I want to set the path. So in Unity, let me just get the folder. So I could just copy the folder here, or the path, to my assets folder. And then I'll use a change directory, Control V. Oops, I didn't copy it right. One more time, folks. Show in Explorer, copy, then go back here and type CD for change directory, Control V, enter. Now I have MLAgents in the right folder. Now to start the training, let me just clean that up. Start the training, I type MLAgents learn -- force, enter. So this will start up the MLAgent library listening to do some learning. And it's going to listen on port 5004. It tells me to press the play button in Unity to start the training. So I go back to Unity, and I'm going to press the play button and start the training. And cross my fingers that the numbers all work out right. And the cars do what I want. So here we go. The cars jiggle, jiggle, jiggle. And they start to learn. Let's just put this window up here so you can see the progress. What happened, there'll be a little progress report here about the mean reward as time goes by. So I estimate this will take about 30 minutes maybe. Training complete. All right, numbers look good here. I think this training's gonna look really well, work out well. So now let's try it out on cars, the new brain. Wait a minute. Why is that brain already there? Let's turn off 2 episodes. What do I have here? I wonder what happens if I do the training and there's a brain there already. Does it train the brain better? Okay, there you go. Oops, I should turn on 2 episodes. There. So it looks like they've learned how to drive, turn around, face the right. Let's see, this guy's turning, backing up, turning around, and going to the wind wall. I say, very nice. All right, in this segment of this self-driving tutorial, we had found out that I can get the cars to drive straight down a road and hit a target at the end. Now I want to see if I could get the cars to learn to drive straight down a road, turn a corner, and hit the win bar. Okay, so this is my lose bar, this is my win bar. These are 2 barriers that I'm calling barrier yellows, and these are 2 barriers calling barrier whites. The theory between having a barrier yellow and a barrier white is just something I noticed to try to control the direction of the cars, because when I drive on the street here in the United States, I have, if you look at the roads, always to the right there's a white line, and always to the left there's a yellow line. And I figured, hey, you know, that tells me I'm going the right direction, because if the lines are on the other side, I'm going the wrong way on the road. So I figured maybe that could help the cars learn which way to go. So here's a new scene. I'm going to name this scene corner. because that's what I'm going to try to get the cars to learn how to do, is turn a corner to get to their goal. And you know, in this Unity project, I have included the package manager MLAgent package. Okay, so I could communicate with the MLAgent library. And I have a car that I made in Blender that I'm going to use. So let me just bring that car in and just put a car there. All right, I have this organized here. Everything that's in my training scenario, I just kind of put it in a empty game object folder called scenario. And then I have the grass and the walls. They're just grouped up under this empty game object for organizational purposes. And then here's my car. So the car is going to be what I'm going to try to train to move and accomplish this task. So right now it's just an FBX that I pulled in from Blender. So I'm going to tag this car. And this car, I'm going to put it on the car perception layer. So the forward script worked. Let's see if the forward script that I used when it was just a straight line, if it could work here with the corner. So before I make another script, I'm just going to drag and drop the forward script onto this car here for my corner test. And the forward script it's an agent class script from the MLAgents. So when I drag and dropped it on, it added the behavior parameters, the MLAgent behavior parameters component. This component describes properties for the neural network brain. Okay. It also put on a decision requester component. This component is from MLAgents as well. And I'm just going to tune this decision period down to 1. So it's asking the brain what to do and as frequent as possible so the car is responsive as possible. Then the mesh collider was added when I dragged the script on. And I want to do physics, so let me add the convex mesh collider. And the rigid body was put on because I'm going to use the rigid body to move the car. I'm going to be applying forces to move the car. And I'm going to add a drag of 1 and an angular drag of 5. So the drag is so the car doesn't look like it's moving on ice, so it slows down if there's no force. And then the angular drag is in case a corner of the car is hit, that the car doesn't just go spiraling out of control. And then for interpolate, I'm going to set it to extrapolate for some smoother motion. And these things, they were already there. Something I have to do here in the behavior parameters, and this is the settings for the neural network brain, is I have to give a name for my neural network brain. So I'm going to call this brain that I'm going to be training corner, since this is my scene for corner. The observations are the inputs to the neural network, and the actions are the outputs of the neural network. So observations are things that my car could see. They're basically values that I'll put in, and the actions are going to be values that come out, and those values get translated in my script to actions. Those numbers that come out of the neural network, I translate them into actions. So for the actions, there's 2 types of arrays. There's the continuous actions array, and there's the discrete branches. The continuous actions array would be floats. But here I'm going to use the discrete actions array, which are whole numbers. I'm going to have 2 outputs from the neural network. On the first output, there'll be 3 possible values, and those would be 0, 1, and 2. And then on the second branch, there'll be 3 possible values, 0, 1, and 2. So on the first branch, I'm going to use that for movement, and the different movements could be forward, backward, and don't move. And for turning, there's 3 because there's turn left, turn right, and don't turn. The model is where I'd specify the ONNX file. This is after a training is complete with the MLAgent library in Unity. MLAgent library will produce a ONNX file and place it here in my assets folder, results folder. And the rest of this stuff I don't have to worry about. So here's my script that I drag and dropped on there. Let's take a look at the script, which is the same script right now as I used for the forward scenario. This includes the MLAgent package into my script. These are the components that got added when I drag and drop the script, and the only one that's not mentioned here is the behavior parameters, because the agent class itself puts that script there, and I could go to definition of agent class and see the methods that are available from the agent class. Agent derives off of model behavior. This is my reward info structure, and this should work because I'm going to have a reward for moving forward, a punishment for hitting a barrier, a car, and then, oh yeah, I made it a big fat win value in the forward movement. And then if I lose, I do a big fat lose value. I have my move and turn speeds that I'm going to use on the car. Here's an instantiation of the reward infrastructure. And then I have this variable called do episodes here. I just added it as a flag to know whether my script itself should end episodes or not. Because when I'm going to use the same script, if I'm not in training mode, I don't want episodes to be ending. I want everything to keep going. So I got a bool. Then privately, I have my rigid body. I have two things to hold the position and the rotation of the car when the game started, and the bounds of the car. So here, all the things with public override. These are overrides from methods that are defined in the agent class. And these public override methods, they're the ones that allow me to communicate with the MLAgents library and the brain. So initialize is kind of like start from model behavior. It runs once when the game plays. So here you see I make sure the values are right on my rigid body and the mesh collider and the decision requester. And then I get the bounds set to BND, and I get the recall position and rotation. On episode begin, the training happens in episodes. So at the beginning of every episode, I kind of reset the car. So I make sure the car is not moving, and I put it back in its original position and rotation. On action received, this is how the neural network brain communicates to my script. Okay, so on the output of the neural network, I have two values, and I keep showing this for every training scenario, but I'll just show it again just in case you had just jumped to this one. Neural network. A visual of a neural network on a computer. You could just think of it as nodes. These are values that come in. These circles are nodes. Then in the middle, there could be any number of nodes, and then at the end, there's a node. So the way the neural network brain works in a computer is you send in some values, some observations about the scene, like how far I am from something, how fast I'm moving, whatever it is that you decide will help your car decide to know how to drive best, right? So you send those values in. Over here is where all the magic happens with the MLAgent library. And then on the output, there's a value that says, what should I do? So you give it all the scenarios that are happening in the scene, and then it gets out of output. What should I do? Should I keep driving forward? Should I turn? Should I, So in my scenario here, I have two outputs, one for move and one for turn. Anyway, the on action receive is the thing that receives the outputs, is the thing that's receiving the values on this side. And the decision requester component is necessary to be on your game object, so on action received is called from the neural network library. Is wheels down, that's a function I wrote down below that makes it casts a ray cast to make sure I'm close to the road and the wheels are on the road. Here I just get the speed of the car, the velocity. Then I translate the actions. Remember there's two. The actions array, the action buffer thing. It basically has the continuous actions array and the discrete actions array. So I'm using the discrete actions, as you can see here, because that's what I set right here, the discrete branches. So in the output at position 0, if the value is a 0, I don't do anything. If it's a 1, I'm going to move backward, and if it's a 2, I'm going to move forward. This add reward method is me telling the brain, I like it when you move forward. So the more positive a value is here, the bigger the value is in the positive direction, the more I tell the neural network brain that's being trained, I like it when you do this, I like it when you do this, and that kind of would have the MLAgent library train the brain to do that more. So what's my value here? Well, by default, it's a positive 0.001. Now the magnitude means the faster I'm going, the bigger the value is going to be. So guess what that should do? What I expect that to do is not only will the car move forward, but it'll move forward as fast as it can. So I'm going to train the brain to move forward, and since I'm using the velocity, which increases the reward when it goes faster, I'll train the brain to move the car forward as fast as it can. Then for the turn, it's the same thing, except turns on the array position 1. 0, don't turn, 1, turn left, and 2, turn right. So this translates the outputs of the neural network brain into actions. Okay? Heuristic, this is a method from the agent class that allows me to simulate the neural network brain myself. All right, so I get a chance to define what these action values are. And I use this before I start my training to test to make sure that everything is set up right. I control the car myself, right? So first I set the action for move and turn to 0, which is don't move, don't turn. Then I read the input manager's get axis methods. If move is less than 0, then I know I want to move. I want to set the value to 1, which is going to get translated in on action received to move backward. And if it's greater than, then I set the value that would be translated in on action received to move forward. And the same thing with the turns, except that's in array position 1. So a 1 would get translated to move left, and a 2 would get translated to move right. All right, so far I got the controls here and the initialization. What's going to happen as the game is playing, if the car hits the barrier white or the barrier yellow, if it hits one of these barriers, then I'm going to add a punishment. So there's no function called add punishment, there's just add reward, but the fact that it's a punishment is because barrier is going to be negative. Okay, the same thing, if I hit a car, then I send a punishment. And then if I hit the win bar, this green bar over here, that's the goal of my whole training, then I add a reward, and hopefully the win reward is the biggest reward there is in the whole scenario. And then I can end the episode because basically the goal has been met. I can end the episode and start another training episode. If I hit the lose barrier though, I'll add a lose punishment value and end the episode too. Then is wheels down, like I said, I just do a ray cast from the position of the car to the relative down of the car. So this is the game object transform up. There is no dot down, so I had to use up and just negate it to be the down direction. And how far down do I cast that ray cast? That's where I had to use the bound. So the size Y just below the wheels. So halfway, but a little bit more, 0.55, just a little bit more than below the wheels. If I'm close enough to the road, then let the car move. So it's not a lot of code. This is the same code as the forward. We see if this is going to work. So let's go over here, and the first thing we should do before we do anything is we should give the car its observation data. See, we have it here set to 1. We leave it as a default because I'm going to use a MLAgent object to send in the observation data to the neural network brain, add component, MLAgents, blah, 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 ray perception sensor, and then you see these rays that shoot out from the car. Those are going to be the observations, and I don't have to worry about the count of the observations. The ray perception sensor component will take care of that for me. But right here, let's see, what do we want it to detect? In my game, in my project here, I have made some tags, right, for the different types of objects. So, whoops, let's go back to the car. So let's just add the things I want it to see, and I specify them by the tag. So the car, the barrier white, and the barrier yellow, and the win. This is the win bar. It's tagged win, and the lose bar in red. It's tagged lose. So those are the objects that I want the car to be able to detect, and all these objects I just want them to detect it if they're on the car perception layer. So there you go. And the other thing that's important that I want to change here is the stacked raycast. Since the car is an object in motion and I want the training to happen based on, motion occurring, I could give the stacked raycast not at one moment in time, but I could give it a history of raycast back up to any number of steps, and I'm going to choose to give it a history of the raycast back up to 8 steps. And what I believe that's going to do is enable the car to make some complex decisions like backing up and turning around to face the right way. It has a history of raycasts. So the ray perception sensor, now my car has its observations and actions, everything's set up. I just want to test to make sure I can control the car so that the action received is all set up right. So I'm going to press play, and I'll try to move the car with the keyboard keys first before I start training. Okay, so here I am. I can move forward, I can move backward, I can turn left and right. If I hit a barrier, it doesn't reset an episode. But if I hit, bam, if I hit the lose barrier, bam, it should reset the episode. And if I hit the win barrier over here, it should reset and do another episode. Good. So the controls are set up right. My collisions are set up right. Now I can start the training since I verified that. And let me just get the camera nice. So there we go. Camera, Control Shift F. Now I have my MLAgents here that was running, and I can start a new training. So here's the car gray. The brain's name should be corner. And let's see if the training is going to work and control the car. MLAgents, learn. And I always use the force option myself. Press enter. So the Unity logo comes up, and then it tells me it's listening on the port. Press play in Unity. So here I can press play in Unity. And if everything's set up right, this is still testing, then the car should be moving. And it's not me, it's the MLAgent library moving the car. It's this, the MLAgent library is controlling the car. Okay, so that works. So I can press stop. Now to increase the training speed, I'm going to duplicate the cars. So the more duplicates I have, the more training experiences are being fed into the brain, and therefore the training happens faster. Okay, so Control D, let's just add a couple of cars here. So I got 7 cars, and now let's try to start the training with 7 cars. File save. Oh, this camera's getting in my way. How do I turn that view of the camera off? There, make them smaller. Turn off 3D icons. Okay, so now I can start the training. MLAgents. Oh, wait, before I start the training, let me check what the reward values are. Because when I did the other track, when I did the scene that was to move forward, I had to set the win to a 5 for it to work efficiently, for it to get good results. So here, let's just start that with a win set to 5 as well. And maybe this will work to train to move the corner, just like it did with forward. Okay. So, oops, is this still waiting for me? Nope, it timed out. Darn it. All right, I'm going to have to start the MLAgent training one more time. MLAgents, learn, force, enter. It took too long to press play. It's playing around too much. And then press play. And there you go. It's starting to move things around. And, ooh, wait a minute. I'm going to stop the training. I didn't really have everything finished being set up. That max steps, these cars are jiggling and wiggling and jiggling and wiggling, and they may not hit this or this. And therefore, you know, an episode may not complete for a long, long time. So what I'm going to do here is on my script, this max step variable, that's not coming from any variable I made. That's a variable from the agent class. And the max step, if it's 0, then there are no maximum steps in an episode. And sometimes I could like not have anything happening because they never hit the things that end the episode in my script. So I could just tell it to end the episode, and in my other one I picked a big number like 5,000 steps. So now I'll try MLAgents, learn, force. Sometimes I gotta think of all these things. Ah, yes, the training has completed. So let's see here in the window what the rewards look like. This looks good. This looks good. This makes me expect very good results here. The rewards went up. And they should work. I felt like it was going to work because I used the same values I used on the forward. So how much more effort is it for it to learn how to turn the corner? All right, let's put this in the mode where we're going to see the brain in action. So here in the behavior parameters, I will put the corner brain on, the one that we just created, and I'll take off the max steps. I'll put it back to 0. Then I'll press play. And let's see. I have an error. Uh-oh. Okay, just restarted my project. That error, just reported it to Unity. Now, let's see, we got the brain on here. Max steps I put back to infinity. My do episodes is still there, so when the cars hit these barriers, that an episode will start over. Let's press play and see how the training resulted. Okay. So other than the cars crashing into each other, a little much, that car just hit the wall. It looks like it's working. He's trapped in there. You gotta turn around. I don't know. I don't know. It may be able to be better, I think. One thing I noticed, let's see, with all the cars selected, maybe this is why, the win wasn't high enough. Remember in the forward, I set it to 5. So here, let me set it to 5 here, too. And now let me get ready for another training. 1, 2, 3, 5,000 steps. Let me remove the brain. Okay. And let me start another training. So let me just see, MLAgents set to the path of my project. All right, MLAgents, learn, force, and start another training. All right, so press play in the Unity editor, and there we go. They're wiggling and jiggling. This is the window, and we'll let this training occur. Okay, the training is complete, and the numbers look good here. Let's see what it looks like on the screen. So let's change everything into let's change everything into play mode. So I'll pick the corner ONNX file for the brain, and I could turn off the max steps and press play. All right, so something's wrong. The cars are not driving well. I have to think, what do I want to do to change things? Usually when the cars like jitter and they don't move forward a lot, it's usually that there's not enough forward reward. Let's see what happens with these guys. They're coming around, and why'd he turn? He could have got there. So something is wrong. Maybe, let me press stop, and let's think. Maybe the forward reward is too much. Could it be? Let me just try having it down. Or maybe the reward for winning has to be bigger. Well, always try to change one thing at a time. Don't change everything, because then you can't tell what has an effect. So I'll just change the forward reward. And did I make it smaller? Okay, 001. This is 00. Let me make it smaller. 5 instead of 001. With the win having a big fat thing. Or maybe it's the barrier. Instead of changing the forward reward, they were moving forward. Let me change the barrier punishment for hitting the barrier, because they kind of kept bumping into the barrier a lot. So let's increase that maybe by, 100% there to 0.01. So maybe they won't hit the barrier. And then we'll start another training. So take the brain off. Make sure you have the max steps and make sure I have that checked. So here, let us start another training. MLAgents, learn, force, enter. Okay, and then press play in Unity again. Okay, the training is completed. Let's see how the training went now. These mean reward numbers look good. Let's put the brain on the cars. Make sure the cars are selected. And the brain's name is corner. And I can take off the max steps, put it back to 0, which is infinity, and press play. And then I could cross my fingers, cross my legs, and whatever else I have to cross, and see if these cars learned how to drive around the corner and hit the green thing. It looks pretty good. See, so I increased the punishment for hitting the wall, so it's a little bit better. Maybe I can increase the punishment for hitting each other, But they're kind of getting stuck on the wall. But this is good enough for me. It seems that the cars can learn how to turn a corner and get to a goal. So now, let me just take it down to one car again. And at least now I don't have to reset the cars up. They're already set up. So I take it down to 1. And I could make a fork in the road here. Ooh, I better not say that word a lot. Yeah, I don't know. It starts sounding like something. This is a children's channel. All right, so I got a fork in the road. Let me move this over, make sure it's kind of more centered. That's better. All right, now take the car, and now I already have the car set up. Now let's just see what happens. I'll make a couple of copies of the car. Control D. Control D. All right, and that, I have 1, 2, 3, 4, 5, 6, 7 cars. And let's see what the cars have on them. All right, so now I made this scene called fork. So I think I'll change the name on the behavior parameters to fork. So the behavior parameter component, remember, that's the brain that I'm training, fork. And I'm going to be doing this, I want to do training mode. So let me take off the brain that's set there on the model. I'll take it to none so it's in training mode to train the brain. And everything else should still be there. Decision requester is 1. The ray perception sensor is looking for car, barrier white, barrier yellow, wins and loses. It's looking for those things. Stack raycast is 8, so it has a sense of motion over time. And what else do I have to make sure is set right? Mesh collider is convex. The rigid body, which applies physics to the car, it has a drag force of 1 and an angular drag of 5. That's so the car doesn't just go spinning out like a helicopter just because it hits something. And I set the interpolate to extrapolate so it has smoother motion. And okay, so everything's all set. And the tag is a car, blah, 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 blah. All right, so now I could start a training, but let me clean out all these extra brains. What's that? I'm not recording my face. It's just my voice. Yeah, now everybody heard that. You heard that, everybody? I'm explaining to my sisters that are visiting that they don't have to worry about talking and making noise in the background. You know, that's happened in videos before. Yeah. Yeah, you can see my YouTube videos. Everybody's always talking. MLAgents, learn, force. So now I'm going to start up a new training session. Boom. And these cars are going to train a new brain named Fork, because in behavior parameters, I changed the name to Fork. And we're going to see what happens. So at first, when the training starts, the cars just look like little ants that are moving around, right? They're not even moving like cars. They look very they're wiggling like confused people in a crowd. Yeah. But as the training goes on, see, so the maximum steps in this training is 500,000 steps. So you can think like every time there's a movement, that's a step. So let's calculate how long that's going to take about a half an hour to finish. So that's why I'll come back and check in a moment. I'm going to pause the recording and check in on it. I just came in to check the how the training's going. It looks like they're getting there. But I forgot to set the max steps on my script. So if you look over here in the training, the first thing, there was no episode completed. That may affect my training and make it take slower. So before it continues any further, let me fix that. So I'm going to stop this training, select all the cars again, and on the max step, put it up to 5,000 steps maximum. So episodes happen, because training happens in episodes, right? Right, Evelyn? Right, Adria?
Yeah.
Right. Right. Right, audience? Right, girls and boys? All right, so now I got my max step. I got my due episodes. The brain is off. Now I'm going to start my training over again. MLAgents, learn, force, and press play. Ba-dum-bum. And they start jiggling like ants. The numbers look okay. Let's see how the cars' performance are. So select the cars and turn off the max steps. Pick the fork, brain, and cross my fingers that I got better results now. And better results. Hey guys, look. A fork in the road. So they do. They turn at the fork and they try to go to the green bars. You see that? They wind up picking a side and turn fork. Yeah, look at this guy getting knocked around.
I like that one. That's me.
All right, so I consider the fork on the road training good. It's successful. Okay, folks. I'm going to try making a track now and have the cars go around an actual racetrack. So just the way I made this car in Blender, in the same Blender project that I made the car, I made a track. And then let me bring that track in here. Bam, there's my track. So first let me prep the track's materials. Here there has one material for it, and I'm going to make sure I'm using my NN palette material. Apply. Now I could drag the track into my scene. Boom. And I could drag a car. And, well, before I drag the car on the track, I'm going to tell you what I'm going to do. Let's put this here. And inside the track, we have the four mesh objects. The barrier white, the barrier yellow, the gravel part of the track, and the road. So all these are static. So let me select the parent and just make it static. Change all the children inside. Now for the barrier white, I will say that that is barrier white tag. And the barriers I want the car to see. So I put on the car perception. Barrier yellow tag, and of course that's something the car I want it to see, so I'll put it on that layer. Then the gravel, I'm just going to tag it, but the car doesn't have to see the gravel, it's just going to feel it. And the road, same thing. Now for all these objects here, let's do add a mesh collider. So physics, mesh collider, and these don't have to be convex mesh colliders. I want the colliders to actually be right with the mesh object. Let's do barrier yellow, add a mesh collider, physics, mesh collider. The gravel, add a mesh collider. Ba-doomp. And the road, add a mesh collider. So now with the gravel and the road, on the road, I want the car to be able to move smoothly on that. And the way I'm going to control that is for the road, I'm going to make a physics material. So I say create physics material. Okay, and with the physics material, this one will be for the road. And here I could have the friction values. So dynamic friction is like as something's moving, what's it going to take to slow it down. So the road, that's going to be my fastest moving object, so I'll just put 0. And I'll leave it at 0. So the road is going to be the smoothest moving thing. That's where the cars are going to want to be to get their highest speeds. So I open up the mesh collider, and here for the material, I could pick road. And then on the gravel, which is on the sides of the road, just like a racing game, you kind of come off the road and you're going to slow down. So I'll create another physics material, and this one I'll call it gravel. And if the car hits the gravel, that's where we're going to get a little bit of friction. So I'll just say 1. Let's see how that works out. All right. This track that I made in Blender, if you notice, when I look at something from the side where the normal is, you could see it. Then I made it so that this barrier on this side, you can only see it from the insides. Then from the outsides, you can't see it. So how did I do that? Is in Blender, when it would be a mesh object that had an inside, top, and outside, I just deleted the outside and the top. And I did that so, when the cars are driving around the track, I figure it's nicer so the walls don't get in the way of me seeing the cars. So did I finish preparing the track? Let's see. I have the tag, the layer, and the mesh collider. I have the tag, the layer, and the mesh collider is good. And then for the gravel, I have the tag and the physics on the mesh collider. Oh wait, not this one, gravel. I didn't set the material. Gravel, there we go. See, good thing I was checking. And then for the road, I have the tag and the material. All right, so I think I set my road up now. Now I could drag and drop a car on the road. So let's see, is this going to be my forward? Let's see, there we go. The forward is facing this way. So I could put a car here on the road, and the scales are all matching up, so that's nice already. See, so my car, the scale is 1, 1, 1. I noticed that if the scale was like odd, like 0.1, 1, 0.8, that the physics behaved a little bit differently, and I was like having trouble applying the physics, and the car's acting in a way that I expected. So I suggest that before I bring everything in from Blender, that I apply all the transforms. So the car is at 1, 1, 1. So because the track had the collider on it, when I drag and drop the car onto the track, it just snaps right to the road. Those are heron. Sorry, I'm explaining to my visiting sisters what the sound of the natural wildlife is. Yeah, the natural wildlife outside.
I have wildlife. It's called pigeons.
Yeah, and they go coo coo. But here we get heron, and yeah, they make those sounds. All right, so I got my one car, and we've set up a car before. First thing is I have my agent script that I wrote to control the car and to train the car. So if I just take that script and drag and drop it on the car, I get a lot of objects added. I get the mesh collider, and I want the mesh collider to be convex, so I could be applying physics to it. See, so it kind of gift wraps the car in mesh collider. So that's set up. I have a rigid body, and the car, I'm going to have it have drag force so it doesn't go spinning out of control if it hits something. And I do extrapolate so it has smoother movement across this track surface. Then the decision requester, it's an MLAgent component, and it works with the MLAgent brain to Unity, asking the MLAgent brain, what should I do, what should I do, what should I do? So the lower the number, the more responsive the car could be to its stimuli. So I put it down to 1 because, after all, these are going to be race cars. They're trying to move really fast. They're going to have to make decisions really quick. Then the behavior parameters component, these are the properties of the brain. First of which will be the brain name, so I'll call it track 01. I'm not going to set the observation size because I'm going to use a component that's going to set that. But here in the actions, I'm going to set the discrete branch to 2, so the discrete branch are whole numbers, and the continuous branch would be if I want to use float numbers out of the neural network, but I'm going to use whole numbers. And then for the first position in the whole number array, I want to have 3 values for back, don't move, and forward. And then I want to have 3 values on the second position, which I'm going to translate into turn left, go straight, and turn right. So that's the values for the brain. And then here where it says model, after I train a brain, this is where I find the name of it and put it on there. Then here is the script, and then track, and it has max steps, it has the move speed, turn speed, it has my class that I'm holding all the rewards in, and then the do episodes thing, which I kind of use for if I'm in training mode or not. So if my script ends episodes, since training happens in episodes, but if I'm not training, I don't need to do episodes. All right, let's look at the script, because this script is a little bit different than the NN forward script that we just looked at. It has a little bit more reward values. There's a little bit more objects here in the scene, and I'm gonna have a little bit more actions. The car, I'm gonna make it count for it. So let's look at the script. All right, so the script derives off of agent instead of mono behavior, but agent, if you look at go to definition, derives off of mono behavior. So you still have all the mono behavior methods, and these are the methods from agent. And to be able to use the agent class, you have to include a using statement, Unity MLAgents. This MLAgents actuators, this statement kind of auto-populated itself in my script when I added the on action received function. So you see these functions here with the public override void. These are all the overrides from the agent class that I'm using. And these functions that are overrides from the agent class, they help my script communicate with the MLAgent library, which is a Python library. It's not part of Unity. To use the agent class, you have to make sure that in Unity you have the package manager package. So right here, these are all the packages in the Unity registry. Or I could just look at the packages in my project, and you can see I have MLAgents package installed. If it wasn't installed, there'll be an install button there that you could click. All right, back to the car, and back to the script explanation. So these are my required components that you saw got added on when I dragged on the script. And I would like to have another required component, but I don't know how to require this. On the car, right now it doesn't have any observations that I'm feeding into the neural network brain, but there is a special MLAgent component, MLAgents, ray perception sensor 3D, that provides the input for the observations on the neural network. And that has its own properties, like what do I want these rays to be able to detect? That I could specify. Sorry. Let me get down here again with the tags. So I want it to be able to detect car, barrier white, barrier yellow. Anything else? I don't think so at the moment. Then for the layer mask, that's where I made the car perception layer, so it doesn't have to look at everything in my scene. So first I'll set it to nothing, and now you see the raycast go through everything. Then I set it to things on the car perception layer, so cars and barriers it will see. And stack raycast, so it stores up a history of raycast information through time. And how many steps back do I want to go? 8. And why put the stack raycast up? So the brain could get a sense of motion over time. Okay. So my ray perception sensor is set up. Boom. I got default values here for my script, it looks like. Okay, so let's test to make sure. Oh, let's finish explaining the script. So these are the different rewards I want to do. This is the move speed and the turn speed of the car. Here's an instantiation of my reward info structure. Here's my flag for doing the episodes or not. Here's the pointer to a rigid body so I could move the car with physics. I get the reset position and rotation, and I get bounds. All right, so in the initialize, I just make sure that all these things like the rigid body have the value set the way I want. The mesh collider is convex. The decision requester period is 1. And I get a pointer to the bounds. And I get what the positions are of the car and the rotation when the game starts. Then in on episode to begin, the training happens in episodes, so after a certain amount of steps, I start another episode. So when an episode begins, I stop the car from moving, and I put it back in its initial position and rotation. On action received, this is how, when the neural network brain sends its output values to my script. This is the method that receives the output values from the neural network brain. And those values for me are going to be whole numbers. And I have two branches. So that means in this actions array, I'm going to be paying attention to discrete actions array, not the continuous actions one. I'm going to pay attention to those because, as you can see here in my properties, I use the discrete branch. And first I make sure the car is touching the road, that the wheels are touching the road. Here I'm just getting the speed the car is moving. And now here on the first action array position, on the first output of the neural network brain, if the values are 0, 1, or 2. 0, I'm not going to move. And if I want to apply any kind of punishment for not moving, I could apply it here. It's whatever the value is there. So I definitely want the car to move. 1, I'm going to go backwards. And then if there's any punishment, I'll apply the punishment. And here's where I use how fast the car is going. So if I don't want the car to go backwards and the car is going backwards really, really fast, then the magnitude is going to increase the punishment. Same thing here. If the output value is a 2 on the position 0, I'm going to move forward, and the reward is going to be multiplied by how fast I'm moving forward. So something's a punishment if the value's negative, something's a reward if the value's positive. Okay? Then for turning, I use the discrete action array at position 1, 0, 1, or 2. Don't turn, turn left or turn right. To get the onActionReceive method to be called from the MLAgent library, I need to add a decision requester component, which you saw I have one right there. And just to make sure I didn't forget about it, that's also why I put it up here in the required components. So that's onActionReceived. It translates the output values of the neural network, because all the neural network does is output numbers. It translates the numbers that are output into action for my car. Heuristic is a way that I could control the car through this whole setup by setting the output values, setting the action values of the neural network. So here I kind of set them first to no movement, no turning. Then I read the input manager get axes. Then here, if move is less than 0, then I set the value to 1, so it could be translated to move back in the action receive, or 2 to move forward. And same thing with turning, a 1 or a 2. So far I have rewards that I was setting over here and punishments, right? For movement or no movement. I have some other rewards and punishments that are going to be reactive to the environment. So on collision enter, I get how hard the collision is. And if I hit a barrier, then how hard do I hit that barrier is how hard I punish it. So if the barrier just kind of skims along, I don't punish it so bad. And then if I hit a barrier, I'll end the episode and start another training episode. I'll consider that a fail. Also, if I hit another car, same thing. And then I'll end the episode to get the episodes happening so the training can happen. And then this is my little function I wrote to detect if the wheels are touching the road. I just do a physics raycast down from the center of the game object, the center of the car, and there was only a this transform up, so I just used minus this transform up to cast a raycast down from the car. And it's down respective to the car, because if the car's flipped over, this is going to be pointing up into the sky. But then I could see if the road is beneath the car, and I just scan a little bit beneath the car. I don't just have a scan that goes forever. So if the car was this high up, the raycast just goes like right to here, and it'd be like you're not touching the road. But if the car is here, let me just press Control Z to get my perfect placement. Then the car's on the road. All right, so I explained the script. Pretty much the only difference is I have some different rewards here from the other scripts. So first test is, let's see if I can move the car with the arrow keys. That's my first sanity check. See if things are working right. So let me set the camera, Control Shift F, and then press play. And then I could press forward, backward, turn left, turn right. If I hit a barrier, reset. If I hit this barrier, reset. And the only other thing I have to do is test if I hit a car, but I think it's working. So that's working. Now I could see if the MLAgent library could control the car. So let me go to my Anaconda prompt. Anaconda is the tool that's used to work with the Python stuff that I set up here. Then in the Anaconda prompt, I could start up the MLAgent environment. So conda activate. And the name of my environment is MLAgents 16. Bam. Then I get the path here to my assets folder. Yeah, my sisters are playing a zombie game. That's why you hear those zombies in the background.
Hey, that's rude.
It is true. Then back to the MLAgent library. I could then change directory with the command cd space, then use Control V to paste in the value of the path, enter. And now I have the MLAgents library running in this path. Now I'll start the MLAgent library. MLAgents learn force. Okay, and let's see if that it starts up, and then it's going to say press play in Unity. The library program communicates to the Unity program through ports. Port 5004. Press play in Unity. And then the car should start jiggling around, being controlled by the MLAgent library. And you can see it jiggling around there in the far distance. The values are jiggling and changing. And I just noticed here I didn't tag my car as a car. So stop. That little test is working. Let me tag my car as a car. And let me put it on the car perception layer. Okay, good. I forgot to do that. So now I'm probably ready to try to do a training to see if I can get these cars to learn how to drive this track. So when I'm ready to do that, I'll multiply the amount of cars I have. So let me select it, press Control D to make a copy, and just place a bunch of cars. Control D, dun, 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 Control D, 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 dun, dun, dun. 16 cars. Okay, let's see. It's a nice view of the action. Control Shift F on the camera. And now I'll start a training. MLAgents learn force. Enter. And press play. And the cars start jiggling. And here in the MLAgent window, which I'll have down here on the bottom, you can see that it says what the default settings were for the brain. So this training is going to have a maximum of 500,000 steps. I think that you could think of a step as every time one of these vehicles jiggle. And just to review to you, the reason that the brain that's going to get trained is track 01, okay? Because right here in behavior parameters, behavior name, it says track 01. And all these cars are going to train the same brain. They're going to give experiences to the same brain because all these cars, they are going to train the same brain, track 01. So now we can just let the training occur. All right, so this training, the numbers don't look good. They got worse. Let's see what happens. So I think it's the track 01 brain. Turn off the episodes. Press play. Yeah, they're not moving forward enough. Just up there, you start moving forward. So what would you do? If it's not moving forward enough, I say increase the forward multiplier. There we go. And then we try training again. Do episodes, remove the brain. And then let me just save that and start another training. Dum-dum-dum, MLAgent, agent, learn, force. And I guess it is MLAgents learn, force. And press play. And we'll see what happens this time. Okay.
Like the plots.
This.
This is chess match.
Alright. Let's see how this turned out. Pick the track 01. And they're driving forward now. They're still hitting the barrier. So maybe I could. They really got stuck. Well, they're driving around okay, but they're hitting the barrier still. So maybe let's do something for the barrier. Let's increase the punishment there. -2. And then try another training session. MLAgents learn force. And train again. Okay, let's see how this training turned out. I don't like the numbers. Dang, why are the numbers sucking? What is the value that's gonna fix this? Um, so that didn't look good. Let's turn off the do episodes and put on the brain for track 01. Right there. And let's see how this looks. This looks like a traffic jam over here. And okay, out here he's driving good. But bam! Move out of the way! You just hit the corner there. Why'd you do that? He's turning. Bam! Bam! It's like, come on, why are you guys hitting the corner so much? Alright, think. Try something else. Well, sometimes when things get bad or complicated, I have to reduce it down to simple terms for a sanity check. So I've added all these rewards here for stuff, but let me just simplify everything down again to the way it was when we did our first test for area and forward, where there was only a reward for moving forward, a punishment for hitting a barrier, and for hitting a car. And then I didn't worry about doing the episodes in the script. I just did max steps. Let's see if we reduce things down to the way I started out and then try to build our way back up. And I don't know why I'm having so much trouble with this track. I swear I did some other projects where I was doing it with tracks and it worked fine. Now I'm having all this problem. But it's okay. I mean, did I miss something from when I was working on the other tracks? I don't know. Let me just check. Barrier white, barrier yellow. Over here is a tag. The track is a track. These are on the car perception layer. The cars are tagged car. They're on the car perception layer. Let me check all my cars here. I got a rigid body. I got the mesh collider and it's convex. The decision requester with a decision period of 1. The behavior parameters, named it track 01, 2, and 3. The script, the ray perception sensor, I sense the car, and I sense the barriers. I have the stacked ray cast. Yeah, so I don't see anything wrong there. Then if I look at the script again, the initialization, the on episode begin, well, the on action received to move the car. Okay. The heuristic for me to control the car, that doesn't really have to matter. It's here, the collision enter, where the collisions are being multiplied by the collision intensity. So this could be a thing, because very, very small collisions where it barely hits, they're going to get a very, very small value for colliding. So this could be a thing right here, where the punishments aren't coming in big enough, but I don't think it's that, because look, I got punishment values right there. So I'm going to leave that there for now. And I'll make the change that I flattened out the reward values. I took out no movement, took out barrier. I reward for forward, and I punish for hitting the barrier or a car, keeping it super simple, all the same values, and I'll see how it works up from there. Also, I'm going to do the max steps 5,000 and not do episodes myself. So the episode length is 5,000 for each car. And try it again. So I am mystified, but with patience, I'll see why. In this scenario here, I can't get the cars to learn how to go around the track. What is the factor that I've done differently? So I start this next training with these new decisions I've made for the rewards. Okay, so for sanity check, I simplified things, and now we have rewards. It's kind of odd though, like what's going on here. Now we have rewards, so let's see how that looks. Let's put the brain on there, track 01, and we can turn off these max steps. And now let's press play. And the driving around the track looks better. Ooh, some of them crashed. Went over the fence. And yeah, you came through there nicely. I guess we're going to just say that's a really hard curve. Everybody's crashing up on it. All right, so when I simplified this back down, this is the best results I've had. So the only question I could say is it something wrong with my track? I wonder if I make the track bigger so that the curves are not as tight. Would that make it better? Is it that the road needs to be bigger than the cars? So here with the track 2, let me try that idea if I make the road bigger. Take the track, scale it up somewhat. Okay. Well, as long as I'm scaling, I might also go all the way. So this is definitely a bigger track. Let's see if, oh, wait, I also got to bring it up a little because it's hiding. There you go. And then take all the cars, and maybe I could just, yeah, there you go. I could put them right there on there. And let's see. Okay, the cars are below the road. So take all the cars and upsy daisy. Okay. Yeah, that's better. All right, so now I got a track where the road's a lot bigger. The cars have a lot more space. Let me set the camera up. Control Shift F. Then go back to the cars. And that's bigger than 1. I don't like big fat punishments, so. Well, first, 1. And for hitting a car, please don't hit a car. 0.8 or 0.6 maybe. Forward, blah, 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 blah. Just in case they. Now the track's bigger. I think I won't mess around with this. I'll let it stop for hitting the barrier. So I'll just do my do episodes. Take that off. Okay, this is ready for training. The values are here. The do episodes check is in. And did I set the camera to this view? Control Shift F. Yes, I did. Let's do another training now where the track is bigger and the cars in relation to the track are smaller. Let's try this now. And MLAgents learn force. Dun-dun-dun. Dun-dun-dun. Okay, press play on Unity. And the training begins. So let's play around with this. Then there's only one other thing I could think of that I could try to play around with, and that would be the max steps. But I think usually in 500,000 steps, if I don't see a nice progression of the numbers, I don't really expect the progression to get better if I turn it to 1,000,000 steps or 2,000,000 steps for the training. Oh, now that I made the track bigger and the cars are smaller in relation to the track, look at the rewards. This looks much better. Wow, look at that. That's what was affecting things. Let's see how they drive. Put track 2. Turn off the do episodes. And show me the money. So could it be that scale matters a lot? Okay, they're driving around the track. I like it. Move, buddy. Yeah, it looks like the driving's much better. And alright, so I guess scale of the road to the car mattered somewhat. Why are you going so slow sometimes, buddy? You're gonna get past. Oh, you hit him. Alright, so I got cars driving around a track. Yes. So I'm going to make a track here with a pit stop. So let's just start. This is my road segment. I like to view here cavity mode so the edges are harder. All right, so this is my first thing I have to do is make a road segment to spread across a curve. So here I have my cube, and I'll start modifying this to look like a road segment. So I could have, I'm going to flatten it out a lot, flat. And then the array is going to go along the x-axis, so I can think of it, this is the length of my segment and the width of my road segment. Being that a cube, I'm thinking is about the size of a car. So my racetrack road, it could be wide. All right. Let's see. So next thing I want to do is go to loop tools and start doing some loop cuts. The first loop cut, this is going to be what I'm going to use to pull up my barriers. So loop cut, use this black thing, turn it to number of cuts is 2. Then stretch it out to the edges. And at the edge, face mode, I'm going to select this edge and this edge face. Press E and just pull up barriers for the road. Back to loop cuts. And I know I'm going to have some street posts, so click that. Turn it to 2 again, but narrow it down to like about a square. Then again, click that, and this one over here, hold shift. Then E, pull out like a street post, the road lamp. Then E for the light part, and then select this face and extrude that out. And this face, oops, this one over here, and pull out. I got like street lamps. Okay. Back to loop cut. Now we're gonna make the gravel. So edge, pull this out all the way to where the gravel is gonna be. Okay. Then another loop cut, because I have to make the 2 lines on the sides of the road, the white line and the yellow line. Pull that out to about the width of my road lines. Okay. That could be yellow, that could be white. Depends which way the road's moving. And then loop cut again, and this could be my center dashed white line that goes down the side of the road. Turn it to 2, and shrink that down to the width of a line. All right, there. Now just some more loop cuts, another loop cut here and another loop cut here, so when the road's bending, it bends nicely. So I think I got that part made. Okay, so now the next thing I want to do is get rid of the edges that are not going to be seen, or the faces that are not going to be visible. So on my main road segment, let's do that. That would be these faces here, delete. Also on the other side, the same thing. Because when it's an array, these faces are not going to be visible. Delete. Then on the bottom, these faces aren't going to be visible. Delete. Then on the sides, on the outside, what I'm going to do is I will remove the faces on the outside, because I don't care for them to be visible. And the faces on the top. That way when this mesh goes into Unity, if I'm viewing like this road thing is going to block my view of the car. And that's because, where is it? Right here, the normals. If I turn on the normals, these lines say which side is being drawn. Ooh, and look at that. This side is the side that's rendered. How the heck did that happen? Ooh, I'll check that after I finish. Let me finish deleting the rest of the faces. On this side, shoot it straight on. Delete. And okay, then these street poles, I want them to continue to come all the way down. So I'll go to edge select mode, and then I'll select the, it's kind of hard to select. So I'll just do this and then say view frame selected. All right, there we go. Edge mode, select these edges like this. Oops, that's the wrong freaking edge. It's so hard to pick the right edges. And then I'll say E to extrude and Z to lock it on the Z axis. And I'll extrude down past the bottom somewhat. Why? So in case the road's elevated off the ground, it looks like it's being supported by beams. I could delete these faces here. Then on the other side, let's do the same thing. Let me just select the face and frame selected, view frame selected. Down here, like this, and edge select mode. Select this, this, and this. And then I'll just extrude by pressing E down, but lock it on the Z and, you know, just come down enough so it's past the road. If it elevates off the ground, well. Alright, so I think I got rid of all my additional faces. So now I'll select everything. Frame select everything. Bam. So I could texture this. UV editing. Map materials. Here, pick a texture, image texture. Then open on my desktop I have a texture I made, and then palette, face mode, everything selected, A, and then do some light map pack because I'm going to go by color. And first things first, I'll just put everything into one color block. So let's scale it down to the size of a color block, and then I'll move it into a color for the road. Okay, say dark gray. All right, so that's the whole road. Now I can select pieces of the road. I don't know which is going to be my yellow or my white line yet, but I do know that these are my edges, my gravel parts. So I'll select these gravel parts here. And I can make them a different color or texture. So let me just let me smart UV project these. Smart UV project means they'll map out on the image, on the texture better. And I'll just fit that into this here. It looks like gravel to me. Okay, that's pretty nice. There you go. Then for the white lines down the middle of the road, I'll just select bing, bang, boom. And I'll move these into the white. Now I'm not sure which side's going to be the white or the yellow line. I'm not sure which way this is going to go when I put it on the curve yet, so I'm not going to do that part yet for the texturing. But I can do the walls, the barrier walls. Oh, I think that'll be the Y view. And I'll turn transparency on, and I will select the walls here. Shift, select the walls here. There, so I got the walls. And I'll take the UV mappings and I'll make them like a brown. Okay, so that's kind of textured up. Now go back to modeling mode. I can view the material. And, oh, next step, add the curve. All right, so let me view it head on, Z. And then let me go back to object mode and add a curve. I'll add a Bezier curve. Open up this black box and let me start off by scaling it up to like 20. There, so I could see it. Then I go to edit mode and start editing out a curve. So if I select the control point in the middle, move my mouse away from the control point and press S, I could scale the influence of that control point. If I select one of the outer points and do move, I could rotate. Then if I want to add a control point, I could select the middle and press E, and it extrudes a control point. So what I want to do is just move around, make a track, make some type of racetrack, and then in the end it will connect by saying curve, toggle cyclic, and then I close the loop. So what do I have here are some loop-de-loop overwraps. So I can just untangle that, untangle this, and untangle this one too. Pick the edge. So I kind of have like a track. Now I could put this road segment on that track. Let's do that. Go back to object mode and pick the cube, which I'm just going to call this the road now. Go to modifiers and add modifiers here. So let's add the array, and it does go on the x-axis. And then let's add the curve modifier and pick the curve to bend around. It's the Bezier curve, so it bends around this way. Okay. Then for the array, you just have to keep adding array points until you can connect. All right. So there we go. We got a track, and we could even add hills a little bit if we wanted to, because we'll just go back into selecting the Bezier curve and edit mode on the Bezier curve. And now say I want to add a little bit of a hill over here. I could pick this Bezier curve and I could pull it up a little if I wanted to. Okay. And then therefore, if I viewed it straight on, you can see that right here is a little bit of a hill. And I can even modify the hill like this a little, so it could flatten out before it gets to that. And then over here in this one, I mean, whatever. Let's say I want the hill on the straightaway part, and I want the hill to be, let's pick this. And this, I want to add another segment point in there. Can I do that? Subdivide? Bam, yeah. Okay, let me view it sideways again. And I kind of want the hill to come down before, oh, I'm picking 2 points. We just pick this one, bring this down a little. because I want it to even out before I get to the curve. All right, so I got a big hill right there. All right, so I got a hill. Then I got a sharp turn here, and there's a little bit of overlap here. You can see this little, I don't know if you could see it with the video, but there's a little bit of overlap. I could try to, let me look at it top on. I could try to get rid of all the overlap, see, by just stretching it out. Boom, just to where it just connects. But okay, so that's my track that I made, and that will remain that. So let me go back to object mode, select the road, and let me apply all those modifiers. I'll apply this array modifier, and then I'll apply the curve modifier. Bam. So now I don't need this curve anymore. I can say delete. And now I just have this road. And I think I shouldn't have done that. Let me go Control Z, Control Z, Control Z, Control Z, Control Z. Okay, I had the modifiers. I forgot to separate the parts of the road before I apply the modifier for this road. And this isn't the pit stop yet. I'm just making the regular road part. So what I want to do is I want to split the road up into pieces. So I'm going to select the road. Also, I didn't do my lines for the white and the yellow lines. So I wonder which way it's modifying. So there's only one way to tell for sure. I'm going to go to UV editing, and I'm going to select maybe this side and turn it white. Or I'm going to select this side and turn it white. Or do you think the road's going this way? I don't know. Let's say this side is the white. So I got face mode, and I'll just pick these. Okay, here's their mappings, and I'll just move it on the white. And now just to check really quick, come out of edit mode, object mode, and let's see what side that white line is. All right, so say if I want my race cars to go this way and the white line's on that side, that's the wrong side. That's the yellow line. So let me fix that. These here that I put in the white, oh, I got more than one thing in the white, so I better pick it like this again. I better pick the faces, hold down the shift, and pick these faces. These are going to be my yellow line. Okay. And then these over here are going to be my white line. This is all visual, but when I go into Unity, I want this to be facing the right way. So let's say object mode now. All right, so I want my cars to be going this way. Yellow line, white line. That's what I intend, so I'm just drawing the picture to match what I intend the road to do. Okay, so now let's start breaking this up into pieces. So I'll go back to edit mode. Here's my road segment. So first let's take apart the gravel part of the road. So I will select the gravel faces. I can turn off transparency mode. Select the gravel part of the faces. And I decide I could put the lines involved in there too. Okay, and then I right click, separate by selection. Bam, and this is my gravel part. This stays the road part. Now I have the barriers, I have the left and the right. I'm gonna turn on transparency again. Gosh, I forgot. Was this my yellow side? Darn it, I cannot remember. Let's just, let me just edit mode. This is my white side. Okay, so select the road, object mode, road, edit mode. This is my white side, right? So I'm gonna pick this one here, right click, separate, selection, and I'll call this one my barrier white. Okay, and then select this side over here and separate the selection, and this will be my barrier yellow. Bam. So now I have my road with all the pieces separated. Object mode, modeling. All right, so this here is my yellow barrier next to the yellow line, white barrier next to the white line, the gravel, and the road. All right, cool. So this is my track. All right. Now I could go ahead and apply all the modifiers on the parts. All right, I applied them a little bit too early before. So apply, 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 gravel, apply, apply. And you can see everywhere it has a wrench, there's still a modifier that's not applied yet. Apply, apply. So now this is a mesh. I don't need the Bezier curve. Delete. So that's my track, plain and simple. Bam. Right now, I want to put in a pit stop. So I don't know. Let's say the pit stop's over here, right? What I'll do is I'll have to start off with another track segment, and the reason I want to make I'll make a new collection for this, and this is going to be called the pit stop. And inside the pit stop thing, I'll just start off by adding another cube, and I'll turn this into a little track segment again. Edit mode. But this one will be a little bit different because it's a pit stop. It's not like the road, so it doesn't have to have all the lines and everything. You're just supposed to drive in, get your car checked out, and then drive out. So it can still be wide, I guess. A little bit long. I'm still gonna put barriers. They may be there, but not visible when I go into Unity. I do a cut of 2 cuts and scale it out to the edge. So I'm just gonna need some barriers and face mode, select those edges. This one and this one. And pull it up a little. Okay. Go back to loop cut mode. Now what do I want to do with the loop cut mode here? You come into a pit stop. I really just need the barriers and the road. But maybe I do need to split the road up. So like the car drives in and then pulls into a pit stop. So I may want to actually divvy up the road into pieces. So how many pieces? Should it be like 2 pieces? You drive up here and then go into your pit stop? I'll just do that. Like that. And then for the pit stop, I'm not going to... Okay, for the pit stop, let's see. I may have to break the road barrier a little bit on one side so that the attendees could come out and work on the car. So I'll do a split like that. All right. I'm just making it what I figure is a pit stop. So this could be my pit stop road segment. And that's going to like come out and come back in somewhere. Now let me texture it. So UV editing. And before I texture it, let me get rid of the extra faces. Back to modeling, and let's get rid of the extra faces for the parts that aren't going to be visible. Delete. Then around this side. Delete. In the bottom. Delete. And oops, I didn't get these edges. Delete. Delete. Now about these walls, when you're driving into a pit stop, I guess I do want to see the car. So I'll delete these faces too on the outside. Delete. And on this side too. Delete. All right, so I got, real simple. I got this, I got the walls. Now I go to UV editing, select everything, view the texture map, got to add a material, click the base color dot, image texture, open an image texture from a desktop and then palette. There, now it's image texture apply. So now what kind of picture do I want for the pit stop road? I don't know for sure. Let's just make it a dark color. So with all the faces selected, here's the mapping. Let me just make sure UV mapping, light map pack. Okay, select them all, A, and zoom it into the size of a box, color box on the thing. Then move that over into the color. So I think my road was this dark color. So should I make I'll just make my pit stop a little bit different color just to differentiate. Okay, and then the pit stop walls, let me select those with transparency is on. Okay, good. Select the pit stop walls, and I don't know if I'm gonna make them visible or not, but I'll make them a different color. I'll make them I guess they could be the same color as the rest of the road. Boom, that. So you drive in the pit stop. One side of the pit stop, the wall's going to be disappear. I don't know which side that is again. So if this is the pit stop wall, let me make the curve that's going to be the pit stop curve for when you go in the pit stop. So here's the road segment. Let's go back into modeling. Here's the road segment here's the pit stop segment. I'm going to use a curve to kind of define the pit stop curve. All right. Usually, do pit stops come on the outside or the inside? I think they'll come on the inside. So go back to object mode. Okay, since I'm in object mode, now I will add a curve, and this curve is going to be for the pit stop. So here it is. Let's go into edit mode, and let's say my pit stop's going to be here. So I'll add one here. And then I guess the pit stop's going to come out. This is way too much influence on these lines. And do another extrude and another extrude. Let's have it connect like that. All right, so now let me just position things a little better. Turn things a little better. So what I'm doing basically is using this curve to I'm going to kind of define a little road segment, piece of a road that's going to come out, be the pit stop, and then it'll come back in to the road. So I'm not sure how far away to place it exactly, but that's what it's going to be. So if you're going to come in the pit stop, you got to come in like this. I have enough control points to make it bend the way I want, I guess. Come around this turn. All right, I could adjust the curve afterwards. So here's my segment, here's my curve. Go back to object mode and select I'll call this pit instead of road because this is my pit stop road. Now add modifier for the array, okay, and modifier for the curve that the array is going to follow, which will be Bezier curve. Bam. Okay, see what I'm doing? Now it just needs more segments. Ooh, darn it, I was not on a flat surface. Jeez. I forgot to apply the Z on my curve. Maybe I could fix it still. Look how it's a roller coaster. Hey. All right. So pick the curve, and it's too bad. I wonder if there's like something I could do to just, I don't know. But there, stay flat. Stay flat. Stay with the road. Is that better? I guess. What a curvy little track there. Then come from the view head on. Edit the curve. All right, now let's try to, hey you, come on, give me some more. See, just try to make it like come in like that a little. Come out just enough to something like that. And I'll do some editing of the two meshes after the fact. I'm gonna make you come back in. Yeah, pit stop. Let's see. Oops, I am off the Z-axis again. Okay, I think that now I could maybe apply this, and then I'll do the rest with some editing. Wait, the only thing I don't want to have to be trying to fix, though, is where this connects with this. So maybe, let me just move this in a little bit nicer like this. Okay, let's do that. It's a short pit stop, but it's a pit stop. All right, now go back to object mode, the pit, and I guess I have to split this into its parts too, like I did with the other roads, so the cars know which way to go on it. So pit, edit, back to edit mode on the pit. And this just has the barriers and the road. There's not even any gravel part to it. So I just have to take out the barriers and let's see. So this, and this separate by selection. And I don't even know which one this is really yet. So I'll say barrier, like lowercase, sorry, barrier yellow. And then this side, this, and this. Right click, selection, separate, and this will be barrier white. Let's see. Okay. Then go back to, and that could be the pit. So there we go. We got that separated into pieces. Now what? Now I have the pieces. Let's get rid of all the modifiers here. So modifier here. Apply the array. Apply the curve. Modifiers here. Apply the array. Apply the curve. And the last modifier for the pit. Apply the array. And apply the curve. Now I don't need the curve. Delete. Okay, so now I have the pit stop road. I have the... Okay, so on the pit stop road, some of the things I don't need. So I have to go into edit mode. Let's see which one's barrier yellow. All right, so now when I see it barrier yellow, that's not yellow, that's the white. So let me fix the naming. Barrier white. And then this one is barrier yellow. Barrier yellow. Oh, I had two whites in there, so let me just get rid of the O2 part here. Barrier white. All right. So white is there, yellow is there, and the pit part is there. All right, cool. Now let me just fix this. Let's go to edit mode, and let me just select some of these faces here. View frame selected. All right, so now which faces can I eliminate? Well, first of all, we could eliminate some. Oh, that's not the right thing. Well, I'm on the pit, so I'm on the road surface part. So let me eliminate the faces here. Delete these faces. And then these faces, I can't see. Let me turn transparency on for a minute. Let me turn on vertex picking. And let me move the vertices into beta position. I think that... Now I'm just doing... Ooh, what is that? Why isn't it connected? Control Z. Okay. And this face I may be able to get rid of if I just take these vertices and just drag them down like this better. And over here, same thing. I just drag these down like this. And then drag these down like this. And then this last one here, I'll just move you over here like this. Like so. Alright, so that means I go back to face mode. I can get rid of these. Shift and shift faces. Delete. Bam. So it's going to be a nice cut there. Now for this part, go back to object mode. Select this object. Edit mode. And let's see what faces we can get rid of. Bam. Bam, 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 bam. Delete. Then we can just take that edge and move it in. Okay. Go back to object mode. This object. Edit mode. And with the edge select, take this edge here and bring it in closer. Bam. So this looks good. The pit stop coming off. Ooh, is that a little? I don't know. That's not a crack. All right, now go to, what do I have to select here? What barrier is this? Yep, that barrier yellow. edit mode. Oh, I should go to object mode to change selection and then go to edit mode. All right, what do we got to work on here? Got to delete faces. I'm in transparency mode, so this pole is gonna have to go away. Delete this, this, and this. Let's delete these guys. Delete. All right, there. Now we have an opening up into the pit stop. And let's just clean up the edge here a little better. Same thing with this edge. Clean up a little better. All right. So now the cars could drive off into the pit stop right there. Let's go to object mode again. And let's clean up this side. So let me just select something here. Edit mode. Select some faces here and then do view frame selected. So I could be rotating around on that. Face mode. See, bam, 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 Flintstones, bam. Delete those faces. And then this edge, I'll just roll it back up into here. Now for the pit stop part, go back to object mode, select the pit, floor part, and then go into edit mode on that. And face mode, let's see which ones we can get rid of. Let's get rid of these. Boom, 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 boom. All these faces, delete. And over here, I don't get rid of any. Now I go vertex mode and just start moving vertices into lineup positions here. All right. Oh. Line it up, line it up, line it up. Okay. Line it up. All right, let me just line this up like that. And so that's that side. Now I'll go back to object mode and select this object, edit mode, and we gotta open this up. So I know I can get rid of that. Let's do faces. Delete. Get rid of this, this, and this. Delete. And this object here, delete it. Oh, what are you doing? Goodbye. Delete. Okay, almost there. Let's just clean up this edge. This edge right here. It's gonna be difficult. There's a little gap there. And this side. I guess that's good. Go back to object mode. Let's see what we got. Okay, we have a road with a pit stop. We could say that's the pit stop area, all right? And then now back to the pit stop, the barrier. Which one? I want this outside barrier here. So let's frame selected. Yeah. So what I said is like the cars are going to drive in here, but the people, the little pit stop workers, let me go to edit mode. They're going to have the ability to run in and work on the car. So I guess, you come up here and let me do face mode. I'll just make breaks in the, breaks in the barrier so that pit stop workers could come out and work on a car. Right? So if I have like some little players, and they'll go like, oh, run out here, work on the car, and then run back in. Just make some little holes in the fence there. Okay. So that makes sense now to me. Makes sense. All right. So I made a track with a pit stop. And it's all in its pieces. Okay. So now all I have to do is export it so I could bring it into Unity. So I'll say export, FBX, and I just want the mesh. I think I have all the transformers applied. No animations. Put it to my desktop, and I'll call this my split or I call it my pit stop track. All right, and .fbx, and I'm just select everything's gonna get exported, so export that. Bam. And I'll also save this for you guys if you want to use it. So I'll say save as my blend file, Pitstop. All right, save, and there we go. Okay, I made a pit stop track. Whoops! Before I show you that, I just wanted to show you what happened for the pit stop track FBX that I had exported. I bring it here into Unity, and the track is not showing like the road. Okay, basically the sides are not showing the way I expect them to for the whole track. And I was wondering what's going on. But what's happening is the normals, they're messed up. See, because the track's drawing on the wrong side. Okay, so the normals are messed up for the pit stop track. So let me take that out, take this out from here, and then go back in the Blender. Thank goodness I saved the blend file that I made the track with right here. And let me fix it. So the road was coming out backwards. So what I did was, it's in object mode. I selected the road. Then I went into edit mode. And then over here, I turned on showing the normals. And the normals, I could show a size. All right. But the normals, it says the direction that the road's going to be drawn. And you can see here it's being drawn on the underneath, which is the wrong side. So how could I fix that? I select all the faces. And then I think it's as simple as flipping the normals. Which, is it here in faces? Somewhere. It's in mesh, normals, flip. Bam. And now the normals are drawing on the upside. Okay, good. Let's make sure that the normals on everything are set right. So object mode, pick the gravel. I guess I could do texture view, face view. Okay, I picked the gravel. Go to edit mode. And also the gravel is pointing the wrong way. So all the faces of gravel, mesh, normals, flip. Now they're facing up. Now let's check the other thing I have here. The barriers are probably backwards. Barrier, edit, and not all the barriers facing the wrong way. Just the fences. Great. Oh boy, I think I'm just gonna have to brute force through this whole freaking track because I have two different, not everything is pointing the wrong way, just the barrier. All right, here we go. 1, 2, 3, 4. And I think that's all flipped right. Whew. So now I could turn off the normals thing right there. And I could do the texture view. There we go. That looks better. Now let's save it again. Save the Pitstop blend file. And then file export. FBX. Pitstop FBX. The mesh. apply any transforms, and there's no animations. And export. There we go. File. I guess now I could close it. Okay, let's bring the Pitstop track into the Unity. So drag and drop the Pitstop FBX in here. Click on the FBX, and let's set it to use the NN palette material. Apply. Now I could drag the track into the scene. Everything looks good. We fixed all those normals. And let's just drag this over here. Let's increase the scale, because we know that when the scale is increased, it helps the training go well. The physics work a little bit better. And then let's set up the thing. So first, all of the Pitstop track is static, so we could use that. Change the children. Then all of the Pitstop objects, they need a mesh collider, so we'll add the mesh collider, physics, mesh collider. And now let's go down. Here's the barrier whites. They will be tagged barrier white, and they'll be on the car perception layer. Here's the barrier yellows. They will be tagged barrier yellow and be on the car perception layer. The gravel is tagged gravel. And on the mesh collider, we're going to use the physics material gravel, which is a little bit more has a little bit more friction. Then on the pit and the road, they're going to be tagged road, and they're going to use the road physics material, which is where the cars can move the fastest. Okay. Question. Let's see what happens when we put a car on the track. So we'll take the pink car to be different than using the gray car all the time. And the pink car, we'll tag it car, and it's on the car perception layer. And then we'll drag the NN track script onto the pink car, and we'll go down and make sure all the settings are right on all these components that got added for us. Drag is a 1, and angular drag's 5, and we're going to use extrapolate. The mesh collider is convex. The decision requester period should be 1. Behavior parameters, just in case we have to train a new brain, let's call it Pitstop. The discrete branch, we're going to have 2 outputs. Each output's going to have 3 values. And the script, and we're going to have to add a component so the car could see and observe its surroundings. We're going to add a component called the MLAgents ray perception sensor. There we go. There's the rays shooting out. And it's going to have the ability to see things tagged car, barrier white, it could see, and barrier yellow. So it can see cars and the walls. It's going to see things on the car perception layer. And the stack raycast, we're going to put it up to 8. So it has a sense of motion over time. Okay, so that's one car. Let me just make sure it's moving right. So I'm going to press play. Well, let me save what I got. Press play. Make sure the camera's focused on the car. I think it's focused good enough. Press play. All right, and I can see if I can move the car forward and backward using the keyboard arrow keys. I could turn left and I could turn right using the keyboard arrow keys. And if I hit a barrier, it resets. And if I hit the other barrier, it resets. And let's see. Whoa, there's a big bump when I try to come over right here. That's going to be a problem. I may have to fix the mesh somehow so that this isn't a big bump. All right, so if I want to fix that mesh so it's not a big bump, I wonder if there's a big bump on both sides. This is a problem. Yeah, you see there's a little shadow there. Look at that. That's a big bump. So let's just take a moment to try to fix this. Let's go back in the Blender. So I'm going to open up my Blender file for the Pitstop. Thank goodness I saved it. And let's take a look at that area there. So what am I on edit mode on? The pit surface road. Select some faces of it. And let me do view frame selected so I could get into that area. Okay. Yeah, so right there I could see it. There's a little bit of a There's a little bit of a crack. Let's do frame selected on these guys. View frame selected. Okay. So there's a little bit of discrepancy there. So let's do this. Go to edge mode. Let me select these edges and try to close that up a little. Just look at it from the side here and try to lift it up. Try to make it a little better. If anything, this is the exit point, so it should be a little bit higher. I think that's better for that. And then let me go to the other end of it where they come in. Select the facer 2 over here. Frame selected. Let's see what we got over here. Or over here where it comes in, it could be a little bit of a drop, I think. Right, but definitely not a bump up. So let me go to edge mode here, or maybe even vertex mode. And pick some of these vertices because they are off. Shift, shift, shift. Here there could be a little bit of a drop. All right. A little bit of a drop. Uh-oh, something's going on here because these vertices aren't connected. Let me select both of them and vertex. Where is that? How do I mesh? There seem to be some vertices on the surface of the Pitstop that are not connected. So let's see. A to select all the vertices. Mesh, clean up, merge by distance. Okay, see that 25 vertices there. Now I could go vertice by vertice, and if it's still not connected. Okay, A, mesh, clean up, merge by distance. Let's increase it. Move one. Just one vertice. Could that just be the one that I had because I moved it myself? Okay, that's better. So if anything, over here, you're going to come in from the road. I can drop down into it, but I don't want to be popping up onto it. So everywhere over here, I want these to be, if anything, a little bit lower. Yeah, that was too high there. And this one, yep, too high there. And let's see this one here. Yeah, just make sure that we could come in off the road to the pit stop without a bump. So that's what I was trying to do, is make sure that it could come in here smoothly this way, and the cars are going this way, that it could drop off smoothly over here. So let me just check it again. Pick a face, view, frame selected. So I'm going to pick a face along this side. Let me see the vertices over here. So here the vertices, they should all be equal or a little bit higher to get rid of the bump that was happening. All right, so I think that'll fix that. So go back to object mode, save my Blender file again, and then export my FBX again that I'm going to use in Unity. Pitstop FBX, mesh, transforms, no animation, export. And then go back to Unity, so you could close you. I did save you already. And here, delete this pit stop. Or can I just, let me just try drag and dropping this one, the FBX in here. Oh, I think it makes another pit stop. Okay, so let me just delete this pit stop. Delete. And then drag the new pit stop file in. Pitstop FBX. There we go. And that looks a little smoother now. See, I don't see the gap right there. Now let's just make sure that this has the materials again. Okay. Apply. And I wonder if I'm going to have to apply all the physics and stuff. Okay, it still has static. It still has all the tags and everything. All right, so I don't have to do that. All right, so now let's test out the car and see if I have trouble driving over that bump again. I'm going to put the view like this so I could see the road part really smooth. Control-Shift-F for the camera and press play. Okay, click in the game window and that's better. It's a much smoother drive over that. Good. Now let's put a couple of cars in here and see how they drive using an existing brain that we trained from before. Control D, Control D, Control D, Control D. Looks like they're going a little bit under because there is a little bit of a hill on my pit stop. So I'll just make sure the cars are over the road, because if they're in the road, it's probably going to be a problem with the they'll be stuck in the road and won't be able to move. So I got 10 cars. Now I'll select all the cars and let's try them out using an existing brain from a training we did before. So we go to the behavior parameters and we set the brain to use, let's say, track 1 brain, okay? So I'm not going to have anything special in the code to say whether to use the pit stop or stay on the road. I just made a track with a pit stop. Set the brain, and let me just reset the camera to this view. Control-Shift-F, press play. And we can see the brain, it works. See, the cars are going to come out. And I think I have my do episodes on. Let me uncheck that, because when they were hitting the wall, they were like resetting. But see, so an existing brain, this is a track that the car's brain's never seen before, but using the things it learned about how to drive around a track, it's driving around this track that it's never seen before. Now what's going to happen here? Okay, this car decided to stay on the road. Ooh. Some of them are coming around that curve and then at the last minute staying on the road. So you see, existing brain can work without having to make a new brain. That's good. Simple. That's one of the benefits of the neural networks. Isn't it great? And I even have a little hill there that's working with. I love it. So how could I make a grid-like situation? And let me try using a plane. Add mesh a plane. And here, control the size. Let's say 20 size. No, that's not big enough. So let's say 100. Okay, there we go. Then now I can go into edit mode and do some loop cutting. Boom. 1, 2, 3, 4, 5, 7. Let's just do 8. Okay. And then over here, 5, 7, 8. All right. Now I can select edges. So let me just select these 2 corners, or these corners here, and then do select edge loops. Bam. And I think that has everything on the outside selected. Now I use E and Z. E to extrude. Okay, see, and then Z to lock it. Bam. And just pick it up a little bit to make a wall. Because I need barriers in my situation here. Whew. And then, let's see, go to face mode, select some faces to make like the city blocks, I guess. And it's not going to be perfect. All right, there's like opportunities here to turn in, and now I could say E. And should these be my buildings that I'm going to make here? They're buildings. So I'll say E, lock it, and it's going up straight. All right, so these could be my buildings. Okay. These are the streets. So making like a little town, a little road. So the cars could be driving around here and do turns and stuff like that. Okay, is that cool? I don't know. Let's do UV editing here. And material, a new material, and for the base color, click the dot, use an image texture. I'm always texturing everything with my NN palette. Bam. And we got all this. All right. So let me just look at it kind of like at this angle with the transparency on. And let me select the color to make all the buildings. So that's the mapping for them. UV, smart UV project, okay. Bam. And just select them all, and first off, let me just shrink that into the size of one of my color blocks. shrink it down, way down, and move it into color block. Say the buildings are all like, I don't know, here, like this bluish color. Maybe the roofs could be a different color, just for difference. The roofs. I make the roofs like tar, so like a black. I don't know, black, right? The very dark color. Okay, now for the barriers. Maybe right now, darn it. Let me select the buildings. Just to make the coloring easier. Oops, I don't have transparency on. Transparency, select the buildings, and separate them into their own object. Separate the selection, and I'll say these are my buildings. 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 Okay, I'm gonna go back to my plane. And now when I select stuff, I could say A. Okay, now I get the roads part. I want the part that's facing straight down. So let me look straight down to Z. And now I'm gonna select the part there without the barriers. And then I'll say invert selection, select invert. Now that's the barriers, okay? So now I could right click and say separate selection, and these will be my barriers. All right, back to the road. So now I get to select all the road. And now what do I do? How do I draw corners and stuff like that? Well, let's just do UV, Smart UV Project. Okay. And then over here, A. And let's scale this down to fit into maybe this asphalt I have here. And that scale is really off. And I don't know if I can make it much better. Yeah, I don't know if I can make it much better. Because the asphalt scale is really, really off when the car's going to be driving around. That's not going to look nice. That looks like I'm too close to the sidewalk. I really like to make like these roads here. Let's see, if I select, say, an area of them. Let's say these two pieces right here. All right, then I could move them onto here. I think I have to rotate them. And this will take a lot more work. So I want to rotate 90 degrees. So I just let this pop-up thing here and I could type in 90 and then I could scale it to fit on this. And you see how I have the road there? And this. So, oh, now for the barriers. So go to object mode, select the barriers, and I can give a color to the barriers. What color should I give? So I just go back to edit mode, and then select everything with A, and then UV mapping, light map pack. Bam, bam. Okay, A, and scale it down to a color block. And what color? I've been giving mine brown. So I'll give those brown. So in line with the way I've been doing all the tutorials, let me just make sure let's go back to modeling mode now, and we could view the materials. Let me just make sure that the normals are pointing the right way. So I guess I have to go this, and then, oh, it's not that does it. It's here that has the normals. Just make sure that the walls are all pointing in. Okay, good. And then what about the floor? Object mode, the road, edit mode, and the floor is all pointing up. Good. And lastly, what about the buildings themselves? They should be pointing the right way. Good. Okay, just to make sure, so it doesn't happen like last time. I put them in and then they were like facing the wrong way. So the barriers, I had to have barrier white and barrier yellow. So let's just say that this is the yellow and this is the white. Okay, so, well, I'm gonna have to pick the barriers. I have to go into edit mode, and now I'm gonna have to select the barriers that I am gonna deem as the yellow, which will be on this side, is what I'm saying. Maybe I could do this here. Ooh, now it looks different. All right, so I pick this side, yellow. So, and the other thing that would be yellow then is this side here. So these faces are my yellows. So let's separate them out. Separate, selection. These will be my barrier yellow. And that means the other ones, go to object mode. These will be my barrier white. Alright, so I got my barriers. The buildings are going to have to be barriers too, though. Oh gosh, alright, think about it. This is barrier yellow. Then this side of the buildings will be the barrier white. This side of the buildings will be the barrier white. So let me go on the buildings, edit mode. Bam, 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 bam. These are all going to be side whites that I'll say. Okay, so separate. Over here I can do separate, selection. And this is building, barrier, whites. That's some of them. Oh, I should have selected all of them. You know what, the barrier yellows, let me make them a different color so I could tell easier. Because I kind of, okay, here's my barrier yellow. No, I gotta select the barrier yellows. I gotta go to object mode, then select barrier yellow, then go to edit mode, then do A. So let's make my barrier yellows yellow. And then I'll make my barrier whites white. Object mode, barrier white. That's the building barrier white. Barrier white, go to edit mode, select everything, and then move this into the white. Alright, so that way I can answer, to make things easier when I'm working over here, trying to make sure which side's which. So now I can see if this is yellow, then these will be whites over here. And are they whites? Let me go back to the building, or the barrier white. Okay, so these are whites over here, so I guess I'll just color them that white. Object mode, edit mode, A. I'll just make them white. Just make them white, okay? Barrier white, barrier yellow, and this side's going to be barrier whites. So object mode, select these buildings, edit mode, and select the faces. I can turn off transparency. Select the faces that are going to be white. Okay, white. It's just a color. Then that means these faces are yellow. So on this buildings thing, geez, I had these barriers white. Then on the buildings thing, I selected more barriers white. I'm still in edit mode. I wish that I just had them all to be barrier white together. So if I do separate by selection, now I have these two that I want to select. Let me go to object mode. I have these two that I want to select, and then I could do a join. Oops, I just lost selection. These two I want to select, object, join. Okay, and these will be my building barrier white. And then for the buildings, let's go and pick that and go to edit mode. Bam. Now I'm going to select these faces. 1, 2, 3, 4, 5, 8, 9, 10, 11, and 12. Select all these faces. These are going to be my barrier yellows. So I could color them yellow. Let's move this over to yellow. And then I can separate. Selection. And these will be my building barrier yellow. Since I have building BLG, I'll just name this BLG too. BLDG. Building. And road. And the road doesn't have any gravel parts. I could make gravel parts. Let's see, modeling. Let's see if I can make gravel parts on the road. So go back to object mode, select the road, and then go into edit mode. So if I select all the faces of the road, maybe I could do an inset. And well, that kind of clumsily makes like the inner part of the road, but it's messing up my texture mapping that I did. All right, I'll let it mess up just so I can have the edges like be. So this part of the road, this is the road part of the road. So if I select the invert, now that's going to be my gravel part. So I could right click and separate selection. And this could be the gravel part. Bam. So, oops, I spelled that wrong. Got to put an L there. Oh, not, jeez. Gravel. Enter. Okay, so now I have all the parts of my road, my track. Okay, so I go back to object mode here. All right, some more cars are going to drive around. I messed up the texturing a little bit when I did the inset, but I don't care. I don't care. I could select the gravel part here and change the coloring so I could see that better. Object. No, go to UV editing. Go to edit mode and then select all the gravel parts. See? There's a lot of selection there. UV, light map pack, and then scale it down. Wait, I didn't have everything selected. So here, A. Then over here, A. Okay, now I just had to press A in the texture mapping area. And I can scale all those down and then just move it into a color. Let's see the sidewalks, right? Maybe they could be like the sidewalks people are supposed to walk on. I don't know, whatever color. Grass around the buildings. Doesn't make any kind of sense, but there. Okay? Whoop-de-doo. And all that trouble I did for mapping the road, but I guess it'll help show motion. All right, back to the modeling. Just see how this looks now. Let's go to object mode and just see how the whole thing looks. Fine, I got a track. So let's call this the city. Let's call this the block, a block. All right, the block, like a city block. So I'll file. First, I'll save this Blender file. I'll call it Cityblock. Cityblock. Bam. Just save that to my desktop. And then I will save the actual FBX. File, export, FBX, Cityblock FBX, the mesh, apply any transforms, no animation, export. File, save. So for Cityblock, now let me get my Cityblock FBX here. Okay. So now the Cityblock, where is it? Right here. So put this in the scene. It needs to be lifted up a little. And probably make it as big as the, at least the grass area that I have. And pull it up. And then the car, I'll just put cars around. You could say the cars are going to all come up over here. Let's go look at the car. Let's pull it up above the road. All right, back to the city block. We have to prep it because we just brought it in from Blender. Here in the asset, we want to select it and make sure it's using and then palette material. Apply. Okay, that's step 1. Then step 2, it's static. Everything there is static. And then inside, let's pick all the barrier objects, the barrier whites. We got 2 barrier whites. So let's tag them barrier white. They're on the car perception layer and they need a mesh renderer. I mean a mesh collider. Then we got the barrier yellows. So we tag them as barrier yellows, car perception layer, and they need a mesh collider. Okay. Now, the buildings is just going to be the top of the buildings. Don't need anything for that. The cars are never going to hit that. They shouldn't. Gravel and road. So gravel, we're going to tag that as gravel. We're going to add a mesh collider, and then on the collider, we're going to give it the physics material gravel. And then for the road, we're going to tag that as road. Give it a mesh collider. And give it the physics material of road. Okay. And that's our city block. Things all set up. Now the cars, we have it still set up from the last thing. So the cars are still going to be looking for stuff. Oh man, and they have a lot of space. I mean, is that how big a street should be? I don't think so. Maybe I make the city block a little too big. Let me scale it down. It probably could have stayed at the scale of 1, 1, 1, 1. And maybe the car fits better with that. I think so. Let's see how it works, like with the car, that scale of 1. Okay, let me just, ooh, with this being the white and this being the yellow, I guess I want the cars to learn how to drive with the white on the right and the yellow on the left. So let's have this car pointing the right way first, and then let's add a couple more cars. Control D, Control D, Control D. We could just add cars all over the city. Okay, Control D. We could add some in here. Control D, and in here. Control D, and in here. Control D, and back here. Control D, then we could add some. Let's see this car. Which way should it be facing? Yellow's on the left, so you should be, I want you to be facing this way to learn how to drive the right way. Then Control D, and I'm just gonna put a lot of cars. Control D, just like a city. Okay, Control D. Oh no, where'd you go? I picked the wrong wall. Gotta pick the Z. Control D, Control D. And put some more over here. Control D, Control D, Control D. So looks like I have about 19 cars in here that we could like observe traveling through the city. Let's pick an angle that we could see pretty good at. I guess this angle would be the angle to see everything because the buildings will get in the way. File, save. And the name of the behavior parameters for these cars, if we train our new brain, we'll call it Cityblock. We were able to use the same brain we had, the track brain, when we did the pit stop, and everything worked fine. So what do you think's going to happen here? Do you think we'll be able to use the track brain here and everything will work fine too? There's only one way to find out, is put the track brain on there and let her rip and see what the cars do. I'll try to get in close so we can see things well. All right, so here it is. The cars are all set up. Cars had their brain on there from track 1. Let's press play and see how these cars actually drive around in a city block area. And they're off. What? Oh, I gotta turn off 2 episodes because they were disappearing when they hit the barrier. So they've all gathered up in this corner and they're stuck. So I was not expecting that. It's like they're all getting stuck in the corner. So maybe in this scenario, let's train a brain specifically for a city block because it is quite different than the racetrack was. So we'll take off this track brain here And do episodes is on. Okay, good. So the brain name is going to be Cityblock. So let's go to MLAgents over here, and let's start a new training. MLAgents learn force. So we're starting up the MLAgent library here, and it's starting up, and it's in listening. Now I can press play in Unity. I press play. All right, time has elapsed. The training has completed through the magic of me pausing my video. And the numbers, they don't look good. Whatever's going on here, these cars don't seem to be able to train properly because these numbers are still in the negatives, high in the negatives. Let's see what that looks like. The name of the brain is Cityblock. All right. So looks like we're gonna be having a problem here. Here we go, Cityblock. And turn off to do episodes. Now we're gonna see what it looks like. Press play. The cars are driving. And all right, they're not getting stuck in the corner like they were before, but they're just not moving. So maybe here in this track where they're like an area, maybe this needs to be more like the way it was. Oh, they're moving. But still, so much negative. Look right here. This car right here, these cars in the corner here, they're just stopped. And what are these guys doing? They're doing a back and forth dance with each other. Go forward. Go forward, man. What are you hesitating about? You could have just drove around that corner and passed the other guy. And over here too, they're getting stuck. So something's wrong. And just like every time something else was wrong somewhere, now again, I have to think, what is wrong? Let me just clear out the extra brains. Cityblock. Delete. Now, I could think to myself, why don't I use, maybe if this is more like an area, I could use the area brain. And the only thing is with the area brain, I had the area script or the forward script. And this is the NN track script. But maybe I could look to the area brain to see what the rewards were for things. So we could zero these out, 0. Forward and backward, 0. And what was that? A minus 0.5 and a minus 0.05. And was that a 001 still? That was a 001. And area, if I am, yeah, it didn't have any ending of episodes by script. So here I have ending episodes by script. Do episodes. When I hit a barrier, it's going to end when I hit a car. But let's try these area values. File, save. And then we'll try training with that. So, before we do the training, sorry. Let's get the cars ready to be trained. Do episodes on and blank out the brain for Cityblock. All right, MLAgents, learn force. And ready to start pressing play. So the car's just wiggling and jiggling. And we'll put up this window here to see the training go on. And we'll let the training take place. The results of the training, let's take a look. Okay, the numbers get slightly positive, so let's see what this looks like in car-wise. So we will put the Cityblock brain on here and remove the do episodes check and press play. All right, these are the cars, and they kind of get in an area. Okay, when a car gets off on its own, it looks like it moves around fine, but when it's together with the other ones here, it looks like they get very confused, like they don't know how to find a way out. So, but it's looking a little bit better. So maybe I could just play with the numbers just a little bit more to get some better results here. So the cars, let's put this back in the training mode again. And let's reduce the penalty for hitting a car low. and maybe increase the value for moving forward further, a little bit better. So we're going to have that for the cars. Let me save that. Then we'll start a third training episode. MLAgents, learn, force, enter. And I spelled something wrong. MLAgents, learn, force, enter. Okay, and we start another training episode. There we go. All right, now we can see the numbers are very good for the reward. All right, the training finished. Numbers look good. And let's put on the model Cityblock. Turn off the do episodes, and let's see what this looks like. Okay, so we got cars racing around, moving very quickly with the higher forward reward. Yeah, look at this guy. So these, I think what happened is if they get knocked off the road, like, if they're not touching the ground, they're not supposed to move. So that may be what's happening with these guys. When they ram all up in a corner or pushing on each other, it's going to be hard for them to keep moving. It's happening in other parts. They're really getting stuck over here. Would you stop trying to gnaw into that guy, for God's sakes? Otherwise, the ones that aren't stuck in the corner, moving around pretty good. All right, so there we got the cars driving around some city blocks. Oh, he finally turned off, and now he's moving. Kapow! Whoop! Sometimes they tap each other. They're really getting stuck in this corner, though. So, I don't know. Good enough. Good enough. We see that I got better results as time went, and I changed things. So, what other kind of things could we practice? All right, this is take 300. I have done some racetracks where there was a barrier, and the barrier was always the thing I was using to keep the car on the track, and then the AI cars would detect the barrier and try to turn away from hitting it. But what about a track where there is no barrier? What about where there's just a flat road? Can I get a car to train to stay on a flat road? So first off, I had to make a flat road. So here I am in Blender, and I'm going to make a flat road. So I have a new project here. I'll first delete these objects, and the only object I need is a plane. So I'll put a plane there. And I'll turn this plane into my road segment. And since it's going to be a flat road, this is going to be a lot easier than the other road segments I made. So go to edit mode, and let's just start changing this up. I know when I do the array modifier, it's going to go on the x-axis, the red axis. So I'll stretch the road out a lot on the y-axis. And I'll tell you why I'm going to stretch it out a lot in a minute. So first, loop cuts I want to make are going to be separating the road and the gravel from the grass. So that's my first loop cut, separating the road and the gravel from the grass. And I'll let it be that big, I guess. Okay, and then the next loop cut in there is going to be the road part. Separate it to 2 and stretch it out. All right, so this will be the road, these will be the gravel, and these will be the grass. And the reason I have the grass is because, I want the car to stay on the road. There's not going to be a barrier to stop it from coming off the gravel. So if the car comes off the gravel, I want a little bit of area here for the car to be able to turn back around and come back to where I want it to go. Okay, so road, gravel, maybe caution zone is what I'll call it. And then out here, that could be the grass. Let's texture this. So UV editing. And face select mode, material properties, a new material, and we'll set the base color to image texture. And then we'll open an image texture, use my NN palette 01. And over here it didn't load. So I'll just load it, image, open, NN palette 01. There. So the road and the grass, that'll be these faces here, 1, 2, and 3. And I'll do UV, Smart UV project, okay? And then I'll take these, A, and I'll move them into position over one of my images that look like road, like this here. You could use the scale tool to get it to have a really good fit. And let's see, over here we have these lines that are coming. So maybe I'll select those 2 lines. Can I do that? Or do I have to select the points? Okay, I can select the points. And then I could scale in that part to be the road, give the grass a little bit. There you go. Okay. And now these two outside ones, this is going to be my caution zone. So smart UV project. Okay. Select these guys and have them just fit into the caution zone. What I have is a material to display caution. All right, so I got my road kind of mapped out with some textures on it. Now I just have to make a road out of it. So let's look at it locked on the z-axis and go back to object mode so we can add a curve, a Bezier curve. And just make it big enough to see. And now we could go into edit mode and start editing out a road. I can click the center point, move my mouse away from the center point and use S to scale the influence of a point. Then I could also just move a point. Select it and move it. Try to make some road out of it. I could use E to extrude more points. And come up with something. And then like connect the loop with toggle cyclic. Some of these points there are kind of twisted. So let me unravel them. Unravel. Unravel. But eventually I'll have something I like that looks like a road. And maybe if there's some places where the turns are too sharp, I could just try to change it a little. But I basically have a road with some curves, okay? Now let's go back to object mode and select the road, which I'll name road, and add modifiers, have the road follow along the curve. So the first modifier is the array. Second modifier is the curve. On the curve modifier, I specify the Bezier curve. And look at that. That's odd. Okay, let's increase and wrap around. And I just think that here it's too tight a turn. So I'm in object mode, select the Bezier curve, and go to edit mode on the Bezier curve. And try to, yeah, these points are going to be too close for my fat road. So we're just going to have to move some of these points. Oops, that's not movement, that's scale. Here, movement. Just move things around so the road doesn't collapse on itself that much. So it doesn't pinch itself as much as it's doing right now. Could do that. Over here it's pinching itself still. It's okay if it pinches a little bit. And now go to object mode, and on the curve, on the road, we need more array pieces to be able to connect. All right, so we have it all connecting. So that's our road, and you notice it's much wider because as the cars are driving around the track, they're not going to have a barrier to stop them. They're going to skid right off. So I just wanted to make the road a lot wider. So we have the road. Now let's put the road and separate it into the pieces that we need. So I'll select the road, go back to edit mode on it. Okay, now we see the pieces here simply. So first we're going to have, let's see, I can't tell which way is which. Let's take off this side here. And we'll say separate the selection. And we will I'll just assume that this is the yellow, right? So I'll call this barrier yellow. And then I'll take this side and, well, let's see, with barrier yellow, let me zoom out. That's actually that's the barrier white. That's on the outside of the line. So let me just call that barrier white. Then that means this one here, this one I could separate, and that will be my barrier yellow. So I'm going to use these caution zones as my barriers. They're not walls, but they're ground segments that I don't want the car to pass over. Then for the grass, I guess we could use the grass also like this. Well, I mean the gravel, but I wasn't using it like that before, so I'll just use the gravel as one piece gravel. So I'll separate that selection and call that gravel. And then the road is the road. Okay, so now if I go back to object mode, everything's there. And I have all the pieces of my road. So I have the white, the yellow, then I have the gravel and the road. So I have my road broken up into pieces. Now I just have to export this out. So file, let me save this as my flat blend file to my desktop flat. Save the Blender file. And then let me export it as FBX. And, ooh, I guess I want to do the selected objects. Oops, I got to hold down the control key and select all my 4 objects. Export the selected objects, mesh, apply any transforms, no animations, flat FBX, export to my desktop, bam. Alright, so now I want to take that track I made in Blender, and I want to bring it here into Unity and get some cars to see if I could learn to drive around that track. So let's get the FBX, drag it in, where'd it go? It's right here, flat. Okay, so first thing, I want to make sure I just want to use my material that I created in Palette 01 inside Unity. Then I kind of drag the track here, and let's scale it up. Bigger. And kind of center it a little bit better. And you notice it's like right in line with the grass. So let me just try to bring it up a little. There. So it's right above the grass. Just a little bit above the grass. All right. And save. Now the track, it's called flat. Let me drag it in my scenario here. And now let me start setting up all the objects. So all the objects, they're not going to be moving in the game. So I'll click static. And actually all the objects here on this track, you know, the 2 barrier parts of the road, the gravel part of the road, and the road, since I'm not using barriers that are vertical, I'm going to have them all be detectable on the car perception layer. So I'll choose that. And while I have them all selected, let me add the mesh colliders, physics mesh collider. So I have the colliders added. All right, now let's go one by one and do the tags. So barrier white, barrier yellow, that means I'm going to want the cars to be driving this way. So let me tag barrier white, and let me tag barrier yellow, and the gravel, and the road. All right, so they're tagged. Now for the barriers, I made a physics material. Basically, the road is going to be the smoothest thing for the cars to drive on, and then as I move away from the road and I hit the gravel, this grass part here, that's going to be harder for the cars to drive on, and then the barrier is harder yet. And then the grass, the Unity block, that'll be the hardest thing for my car to drive upon. So the 2 barriers, for the physics material and them, I'll just pick my barrier material. Then for the gravel, I'll pick my gravel physics material. And the road, I'll pick my road physics material. And then I did say that this grass, this Unity cube, is going to have a physics on it. So here, I made sure the grass was tagged grass on the car perception layer, and that the physics material on its collider is grass, which is the most difficult for the car to drive on. Okay, now for adding a car. Let's see, I've done the gray car, I've done the pink car. Let's try the navy car. It's the same car, just colored with a different color texture. Let's put a car there, car navy, and let's take a closer look at the car, and just position it a little better. So the car, same thing. Before I drag the car in, let me look at the asset in the window. Yeah, it's using my NN palette array. Okay, cool. So the car, I made a script for the car, NN flat. And it's different than the NN track script because the NN track script, you know, I had barriers that were vertical. So I just wrote a different script, NN flat. And this script is derived off of the agent class from the MLAgent library. I'm going to drag it on the car, and some components will be added automatically for me. Rigid body, so I could do physics to move the car. I want to set the drag to 1 and the angular drag to 5 and interpolate to extrapolate. the mesh collider, convex. The decision requester is an MLAgent component, and it asks the brain for a decision, like what should I do, what should I do? And the decision period, the lower the number, the more responsive the car will be able to be to its stimulus. This is a racing game. I want it to be the most responsive possible, so I drag it down to a 1. Behavior parameters, this is the settings for the actual neural network brain. So the name, that's the name of the brain, flat, since I'm on the flat track, and so I'll name the brain that's going to be trained, I'll name it flat. Vector observation is what the neural network brain can see. Those are the inputs to the neural network. Like here, vector observation right now by default is set to 1, and I'm gonna leave it at 1 because I would only change the values here if I was going to manually in my script be setting observation values, but I'm going to use a MLAgent component for that. Here in the actions, I got to set that, like how many decisions do I want my brain to do, how many output values. So I'm going to have 2 output values. The first one is for move, and there's 3 values for move. There's move backward, don't move, and move forward. Then the second output value of my neural network is going to be for turning. It's going to be turn left, don't turn, or turn right. So that sets up my neural network brain. And right here for the model, I'm going to leave it blank. The model is actually the neural network brain file, the ONNX file that will get created when I do a training. When I leave it blank and I press play in Unity with the MLAgent library, then the brain is getting trained. When I put the brain there, then it's going to use the brain. But I'm going to leave it blank because I'm setting this car up to be trained. Then here's my script. The maximum steps, this is the maximum steps per episode, since the training happens in episodes. Like, it's kind of like looping over in time, like, okay, start over and try again, start over and try again. Those are episodes. And how many steps in an episode, if the max steps is set to 0 right here, then I'm going to have to end the episode in my script somehow, which that's what I'm going to do in this script. The move speed, the turn speed, and these are all my reward values. Negative values are punishments, and positive values are rewards. And the amount of the value is how much I want or don't want something to be happening, to try to train the brain to get the most reward. That's what the MLAgent library is going to do. It's going to try to train the brain's neurons to get the most reward as it's testing out doing the training. And then I have this little variable here that I put on my script called do episodes. So when I'm doing the training, I could click do episodes, and then my script will actually end episodes, like when I hit something like a barrier. But then when I want the car to the game to play, using the brain, I'll uncheck this, and then we'll just see what the car does. If it hits the barrier and goes through it, it'll go through it. And is there any other components? There are no other components that were added automatically when I drag and drop my NN flat script on there. But like I said, I'm going to have to add one more component myself to get the vector observations, the inputs to my neural network. And that component is add component, MLAgents, ray perception sensor 3D. Okay, and you can see there's some rays that shoot out. The rays are shooting out horizontally, parallel to the road, because that's the default. But I don't have any barriers that are sticking up vertically, so somehow I'm gonna have to make the rays go from the car and aim a little down so I could detect what's on the floor. So let's open up the ray perception sensor 3D component. First thing is, what do I want it to be able to detect? So I'll just add the tags for all the things I want it to be able to detect. A car, a barrier, white, these are the tags. A barrier, yellow, gravel, that's this green grass part right here, gravel, and road, the road that I'm driving on, I want it to be able to detect and see where the road is. And then the last thing is this outside grass here, should you go past the barrier. Grass. Okay, the rays per direction right now is set to 3 rays per direction. I'll leave that by default, set to that. The raycast, the stacked raycast is the history. So I have been setting it to 8. So I'll try setting that to 8 here. Start vertical offset, that starts right here in the center of the car, vertically center of the car. And the end vertical offset is still the same thing, that's why it's not hitting anything. But if I do drag it down a little bit, I can actually hit the road, hit the ground. And these spheres here, they're pretty big, and it looks like it's kind of upsetting, like how far the things it is could see. So I'm going to try to make the sphere cast a little bit smaller. 0.1. Okay. So let's go down a little more. 0.5. Are there sphere casts on the net? There are. They're just so very small. So maybe I'll make it like 0.2. And of course, the bigger the sphere cast is, the shorter the road is. Now, it's seeing the road very, very close in front of it, not giving it a lot of reaction time. So let's make this point. Let's see when it was 0.1. It's not hitting 0.2. It's hitting. So I'll try 0.2 for the ray cast so I could see the road in front of it, like what's there. All right, so I have everything set on my script and the car. Now I just want to do a little test run. I want to press play and see if I could control the car with the keyboard, and that when I hit, well, the barrier is that it resets. But forgive me, I didn't go explaining the script to you guys and girls. So let me open up the script and explain it. So this is the NN flat script that I wrote. It's gonna use Unity MLAgents, so I could use the agent class. And then it also added this using statement MLAgent.actuators for the action buffers object. So here in the onActionReceive function, there's action buffers, and this needs the Unity MLAgents actuators to be included for it. These are the components that got added automatically that I decided to put there, like the rigid body mesh collider and decision requester. And you saw that when I drag and drop the script on, that it added those components automatically for me. And here, this is what makes this class, this script, work with the MLAgent library, is that the script is deriving off of the agent class. And you could easily right-click on the agent class and say, go to definition, and see all the methods that the agent class is going to be adding for you right here. I'm only using some of them. Here, system serializable, public class reward info. This is a class inside my class, and this is just organizing my reward values so that when I see them here in the in my script, that they're nicely packed up in a little subsection. And remember that negative values are punishments, positive values are rewards. Try to keep your values for the rewards between, a -1 and a 1. Oh, like if you could do it with smaller values, better, because that kind of balances out the training so it's not shocked into something. The training happens better. Then here's my member variables, move speed, turn speed, the reward info, instantiation, and the due episodes. Here's my private variables, so like I'm using here in the script. And here in initialize, I initialize my private variables like the rigid body, make sure that the values are set right on the rigid body like I set manually there. Then there is the mesh collider that I make sure the value is set to convex, and the decision requester, I make sure it's set to 1 in case I forgot to set it manually. And then the bounds object, I'm going to use this bounds object to see if the car has the wheels facing the road. So I need the bounds to know just how far to do a ray cast underneath my car. And if right beneath the car the road is there, then I know the car can move. So that's what I'm going to use the bounds object for that I get. And then the recall position and rotation is so I can reset the car every episode. So here, just to mention, initialize is kind of like the mono behavior start function. This function gets called once when the game starts. Also, when I'm looking here in the outline view of my script, all these public overrides, these are the methods that I'm overriding from the agent class to make a definition of them for myself. All right, so initialize happens once when you press play on the game. On episode begin happens every time a training episode starts. And remember that the training for the neural network brain, it happens in episodes. And in each episode, there's a number of steps. So here, if I start a new episode, I reset the car to, I'm going to reset the car to stop it from moving. And I'm just going to reset its position and rotation to the same place it was when the game started. On action received, this is very important. This function is very important. This function is when the brain is going to tell my script what the output values of the neural network are. It's when this is where I get the values that come out at the other end of the neural network. Basically, that's the, you feed some values into the neural network does its brain magic, and then you have the output values. That's like the decision of what's going to happen, these output values. So the onActionReceive function gets those output values in this action buffers object, actions, and then I could look at the output values and do something with them. I translate the output values into an action on my game object. So just when I come down here, the is wheels down, that's a function I wrote that I'll show you. It's down below to see if the car's wheels are touching the road. Then over here, I want to multiply the punishments and the rewards based on how fast the car is going. So this is the velocity of the object, and magnitude is, a more accurate number, but it takes longer to calculate. So that's why I just use square magnitude, because all that matters is, like, the faster it goes, I have a larger value. So that's all that matters. I just use square magnitude. It's faster calculation. And the actions buffer thing, this actions thing. So if I look at the actions object and I press the dot, I see the IntelliSense. And in there, there's two arrays. There's the continuous actions array and the discrete actions array. If I used the continuous actions, that means the output values of my neural network, they'll be floats. And if I use the discrete actions, they'll be whole numbers. And how do I decide if I want my actions to have continuous or discrete actions? That is decided over here in the settings for the behavior parameters right here. And it's right here that I decided to use the discrete branch, and I said 2. And the continuous actions is 0. So I'm using the discrete branch right there. Now another thing, you may type this in, this function that you're trying to override, and you may have action buffers have a squiggly line underneath it. That can happen if you don't have this line. So if I take out this using statement here, and then I look at this, action buffers will have a squiggly red underline. So I'm going to tell you a feature here with Visual Studio, Microsoft Visual Studio, the thing that this code is running in here. When you have these squiggly red underlines, you can put your mouse over the thing that the red underline is. Just hover your mouse over it, and a pop-up shows. And it says right here, show potential fixes. So I could click that. And then over here, it gives me suggestions on fixing this. And you see in the first one here is saying, oh, just add the using statement. So I could click that, and the using statement gets added for me. And this red squiggly underline goes away. In case you guys or girls see that happen, you could do that. All right, so here, the first discrete action array position, that's position 0. That's branch 0. There's 3 possible values that I said there. Let me just show you. See, I said 3 possible values for each of the branches. So array position 0, that's, the first branch. If it's a 0, 1, or 2, I will do no action. The car's not going to move, but I'll do the reward for the no movement, whatever that value is. Or the car's going to have a 1, I'll translate that to move the car backwards. And I'll add a reward for backwards. So the method is add reward. There's no add punishment and add reward. It's just add reward. And deciding if it's a punishment or a reward, remember, as I told you, the sign, if it's negative or positive number, negatives or punishments. 0, 1, and 2. 2 is to move forward. And what else can I mention here? That add relative force is so that when there's a force being applied to the car, it's applied to the forward direction of the car, which may not match up to the forward direction of my scene. So if I had just used add force, that's to the scene. Add relative force is with respect to the car. Then there's the second array position for discrete actions. That one I'm using for turning. That's what I'm going to translate to for turns. 0, 1, and 2. 0, don't turn. 1, turn left. And 2, turn right. So this is where the output values of the neural network are translated into actions. In my script writing, I could set the action buffer values myself, which would basically be me controlling the car with the keyboard. Okay? So if I want to control the car instead of the neural network controlling the car, I could use this heuristic function. And in it, what I do is I set the values for the output of the neural network. All right, so here first I set them to 0. Then I use Unity's input manager, get axes, to get the vertical and horizontal axes. That's like the WASD keys or the arrow keys. And then I use those values for move. If it's less than 0, I set the value in the discrete actions array to 1, which will be back. If it's greater than 0, I set it to 2, which will be moving forward. Then the same thing on the second discrete actions position. If it's less than 0 for the turn, then I'll turn left. I'll set the value for turning left. And if it's greater than 0, then I'll set the value for turning right. And the reason a 1 is going to go back or a 2 is going to go forward is because here in the on actions received, I translate a 1 to go back and a 2 to go forward. See, so it's all how I translate the values of the neural network. All right, so that's good. So these things here would be getting values out of the neural network, and the car would respond to those values to control the car. Now, when the training's going on, I have to end episodes somehow in my script. I am going to end episodes in my script. So I'm going to do it with the on collision enter. At all times, you see my car is in contact with something. Here it's in contact with the road. If it's driving over here, it'll be in contact with the gravel. Or if it's driving over this, it will be in contact with the barrier, or even finally the grass. So it's always in contact with something. So when the car collides with one of these objects, I will do something, right? So on collision enter is the moment the car collides with that thing, which makes me think about something. There's also another collision method called on collision stay. Private void on collision stay. That'll be as the car is on the surface. And now, just as I'm talking to you, I realize like some things may be on collision enter that I want to do, and some things may be on collision stay. So anyway, let me finish explaining this on collision enter the way I do have it. Collision relative velocity, that's basically how hard the collision is to, whatever it's colliding with. And I figure, hey, if you hit something harder, punish you harder or reward you harder. So if I collide with a barrier road object, then I'll do a punishment. If I collide with the road, then I'll do a reward. If I collide with the gravel, I do a reward. And if I'm colliding here, these probably could stay in the on collision enter, because as soon as I touch the grass, I want to start another episode. So I punish and end episode. And over here, as soon as if the car hits another car, I want to punish and then do another episode. So these, I'm going to leave here in the on collision enter. Okay, because the on collision enter happens like once. But these guys, let me just copy or cut them out of the on collision enter. And I'm going to put these guys in on collision stay. Oops, it looks like I need the magnitude value up here because this went like this. Control V. All right, so on collision enter, if I hit the grass or a car, I punish and I end the episode. So that's on collision enter. Then on collision stay, if the car is driving over the barriers, then I'll keep punishing the car for being on the barriers, get off the barrier. If it's driving on the road, then I'll reward the car. I like it, stay on that road. And if the car is on the gravel, the same thing, I'll reward it. The values for these things are, remember again, what I set to over here in the reward info. And now I'll explain my last method, is wheels down. It's simply casting a ray cast from the center of the game object, the car, from the car's position down in the car's down position. So whatever the car's up and down are, that's what this is. This transform is the car's up, not the scene's up. The scene's up is always this way. The car's up right now happens to be this way, but if the car is flipped over, then the car's up is this way and the down is this way. See? So I have to do this with respect to the car. Oops, which axis did I just rotate on? It's the blue one. The blue is the Z, so the Z axis is, put it back to 0. So from the car, down from the car, how far down? The size of the car Y, halfway down from the size of the car Y, plus a little bit more to see if the road's there. And that's what the is wheels down is. It's a ray cast. See if the wheels are touching the road. So that's a script explained. Now let's just do a little test run here with this one car. I'm just going to press play and see if I can control the car and what happens when I hit the sides of the roads and stuff like that. Can I control the car, move it forward, backward, etc. And oops, I forgot to set my camera. So let's set the camera looking at this view right here. So I select the camera and press Control Shift F, and you can see now that's what the camera's going to see. Now I press play again. Okay, so now I'm going to use the keyboard here, and I'm trying to move forward. It doesn't move. It's just stuck. Left and right, it's stuck. So something's wrong, and it could be something about what I've done with my on collision enter and collision stay. Well, these just add rewards. They don't do a reset. And over here, this is where I end the episode if I touch grass or if I touch another car. So what do I think is happening? Because I see the car jiggle when I press the keys. And here's on episode begin where it keeps resetting. So first, let me just see if it is coming to on episode begin. So I'll put a debug.log and I'll just put the word stop, just to see if I see that it keeps hitting stop. I'll try this again now, and I'll view the console window because that's where the debug statements come. They come into the console window. Then I'll press play, and I'll see how many times stop keeps happening because stop should happen only once. So right here, stop, I'm not even pressing anything, and it's coming to the on episode begin over and over and over again. You see the number over here for the stop command? It's just happening over and over. So that is not what I expect. So which one is sending it to do the on episode begin over and over? Okay, what I've done is I got to see which one of these guys is kicking off the do episode. So I put a debug log here for grass and a debug log for car. Now, if I go to press play, I lifted the car off the ground a little bit so it's not touching anything when it starts. I press play. Let's see which one it is that's kicking off the touch command. And here you see the number coming up. It keeps detecting that it's hitting grass. All right, so how much do I have to adjust this that I don't have it happening? So let me position my track here and keep raising it higher until that stops. So that's 0.848, 0.47. Oops, not 7. 47, enter. Okay, so at 0.47, that stopped happening. All right, so I took care of that problem. Now drive the car forward, backward, left, right. Okay, so summarizing, what we found out was that on collision enter, hitting the grass kept on firing. And that was not expected because if you look here at the scene, I could clearly visually see with my eyes that the flat track is above the grass. But regardless, the physics was detecting a collision with the grass. So to solve that, what I did was I took the flat and I just moved it up on the y-axis from minus 0.49 to minus 0.47, and then I was able to stop seeing the car reset itself. All right, so let's try to do a training with the car that we have. And right now it's above the ground, and just put it like to the ground there. It seems to be to the ground. If it's a little bit above the ground, it's okay because it'll drop to the ground. And then let's make a couple of duplicates since we know the car is ready. So Control D. And why do we make the duplicates, folks? It's because it increases the training speed. Control D. It increases the training speed because each car being fed the experiences into the same brain helps the training go faster. Control D, Control D, Control D. All right, so I got that many copies. File, save. Now let's start up the MLAgent library. So I'll go to my Anaconda prompt. I'll open that up. And I'll type in conda activate. And the environment I want to activate is the one that I put my MLAgents in. MLAgents 16 is what I named it. So that activates MLAgent 16 environment. And now I just want to change directory to my assets folder. So here I'll just right click and say show in Explorer. And I'll just copy here the assets folder path, copy the address, and then go back to my prompt and I'll type CD for change directory and Control V. So now I have my MLAgents library running with the relative path being my assets folder for my Unity project. So now I can type in the command to start the training. MLAgents learn, and I use the word force. I use the option force, and then the library starts up. You see the Unity logo, and it will tell me it's listening and press play. So now that the MLAgent library is listening, I can go to Unity and press play. And Unity and the MLAgent library, they're communicating through port 5004, which is usually how two separate programs communicate on a computer, through a port. And here we can see the settings that the training is using. And I didn't reset my camera from when I was testing the car motion, but okay, I could look at it from my scene view if I want. See the cars a little further away. And hopefully these cars will start learning how to drive around the track. Let's just try to set the camera up there in the scene view. And I'll view this window at the same time, and now I'll just let the training happen and see the results. Okay, so the training is just pretty much begun. Some seconds have elapsed, or steps have elapsed. And what I'm seeing here is that there was one, like on the first 50,000 steps, not a single car completed an episode. And then here on the next 50,000 steps, the reward is minus 70. Looking at the training going on, I don't see the cars like moving down the road. I see them kind of getting stuck on the barrier. I don't like that. You know? I guess I'll let the training go on a little bit longer and see if something comes of it. But so far, it doesn't look good. Okay, I guess I'm glad I didn't cancel the training because now the rewards are really kicking off. And I could see cars making it all the way around the track. So, whoa, these cars are going the wrong way on the track. And they're not turning around. We'll worry about that afterward. Alright, so the training concluded, and the rewards are definitely positive. They went up and a little bit down. Alright, let's see what this looks like. So, come back in Unity, select all my cars, and now I'm going to switch them into using the brain mode from training mode. So, model, until it used the flat model, because that's the name of the brain right here from the behavior parameters. And I won't make my script do episodes anymore. And then, let me set the camera, Control-Shift-F, and press play. And the cars are driving. They're making the corner. So, nice. This guy's going backwards. Is he ever going to turn around? This guy's going backwards too. So in the earlier tracks where I had the barriers, this didn't have a chance to occur because when the barriers were on the wrong side of each other, the cars kept, turned around and went the right way. But I guess along the training, that never became too much of an issue. So I got a bunch of cars that start going the wrong way. Whoa, all these guys start going the wrong way. So let's say that this training has happened and, we're satisfied. Except they're going the wrong way. Okay. You're all going the wrong way. There are so many steps to remember during these trainings for these cars, and sometimes I forget. So I just noticed when I looked at one of my cars before that the tag was not set to car and the layer was not set to car perception. So even though the cars were driving around the track, and even though I had my rewards here for like hitting a car and I wrote the code for it, the cars were never going to see a car because the cars were not tagged car. And I was like, damn, I forgot that. So I just wanted to mention that. Now I kind of fixed that. Here I selected all the cars and I tagged them car and I put them all on the car perception layer. Yeah, so that was something I missed in the last go around there. The other thing that I did now was I added another reward value here for the car going in the right direction. And you may wonder, well, how do I know if it's going in the right direction? What kind of way could I tell if it's going in the right direction? I mean, my eyes could see that I want the cars to go this way, but how do I tell the computer? How do I tell, in the code that the car is going in the right direction? Well, that's what I use the barrier white and the barrier yellow for. So when the car is going in the right direction, barrier yellow is going to be to the left of the car, and barrier white will be to the right of the car. That is a sign to me that the car is going in the right direction. So let that be assigned to the car. And how I do that in code is this. First, I added my reward info structure. I added the right direction as a value. And let me just see what I put as my value for my right directions. 0.0001. So let me just update that here in the default. 0001, a very, very small value. And then the other thing in the script, back to the script, is I had to write a function to detect the right direction. So just like I use raycasts to see if the car is on the road, in the is wheels down, I use raycast. I cast it down from the car down about half the size of the car to see if the road's right there, a little bit more than half. I'm going to do the same thing to see if the car is facing the right direction. So here I have to add a new method, collect observations. I have a new override to my agent class, collect observations. And I'm going to manually feed in some observations to the neural network. When I add the collect observations method, vector sensor requires, as you can see here, MLAgents.sensors. And that added this using statement for me so that I could use vector sensor. Remember when I had to use action buffers that it had to add Unity MLAgents.actuators over here. So that's what the sensors is for. It's for the vector sensor object. So the sensor object, if you look at it, sensor dot, this is what it has. So I could add an observation. That's the method I want to use. Okay, so when I use the collect observations method, I'm going to have to make sure on my behavior parameters component that I set the vector observation size. So here I'm going to be adding 1, 2, 3 observations. So here on the, if I select all the cars, and I look at my I look at my behavior parameters component, right? Then over here in the vector observation, these are inputs to the neural network. I'm going to input 3 values. And those are the 3 in the script that I'm setting. Then the stacked vectors is so it has a history of those values. I set that to 8. And I picked 8 because in my ray perception sensor for these raycasts that I'm using the MLAgent ray perception sensor, I set it to 8 as well to have a history of scans feeding into the brain. So I just put my vector observations to also the same amount of history, 8 raycasts in history. All right, so let's explain the method and how I worked on it. So I broke it down in steps here. So first step, I want to cast rays to both sides of the car. And when I do the ray cast here, the sphere casting, I could use a layer mask to say what layer. So 6 is my car perception layer. If you look up here and you see car perception, you can see that it's 6. And the way I kind of have to specify the bit mask for the layer mask is like this, with this kind of notation. 1, shift, 6, okay? This less than sign 6. And that will set the layer mask value to the 6 that I could use here in spherecast all. All right, so the first thing I got to get are the positions for I'm doing my raycast. So the road is flat. Okay, so just like before when I was doing the raycast for the flat road, the raycast starts from the center of the car, see, center of the car, and kind of goes down toward the road a little bit so that I could hit the road, because if the raycast just went straight forward, they don't hit the road. So with this one, there's no visual for these raycasts that I'm doing in the script, but I'm going to go from the bottom of the car to the white direction and to the yellow direction. So the bottom of the car, this is the center of the car, so I want to get, first I have the car's position, which is in the center for my FBX, and then I use the bounds object to get down to the bottom of the car, so that will be where it should be touching the road. And then I go to, then that's the first position car bottom. And then the white, I go off here in the plus direction on the X, and in the left, I go in the minus direction on the X-axis, you see? It has to be the car's X-axis, not the scene's X-axis, which could be totally different from the way the car is facing. All right, so the bottom of my car, I just make a new vector from this transform position X, Y, and Z. But on the Y, I just want to add this, I want to add half the size of the car in the Y. So that could be at the bottom of the car. And so you can see the Z right there too, okay? Then, now that I have the bottom of the car, I go in the position of the white, which is going to be to the right of the car's bottom. So I use the car's bottom plus 1 to go in the right direction, the car's bottom Y and the car's bottom Z. And then for the yellow direction is to the left. So it's the car's bottom X minus 1. That'll set it going in the left direction, bottom Y and bottom Z. Now I just have 2 sphere casts that I'm going to do. And I'm using sphere cast instead of ray cast because the road is a, it's a flat object. It's like pixel flat. So I'm going to use sphere cast to make sure that I hit the road, all right? Instead of ray cast all, I'm using sphere cast all. So physics, sphere cast all. So basically it's just going to cast a ray out a length of 20. It's going to cast it out from the bottom of the car, and the sphere cast size is 0.2, and the direction is the pos white, and it's using that layer mask, just looking on the car perception layer. So this should get the road, the gravel area here, the barrier area, and even the grass area. It should get everything as long as the length is about 20, which these rays here are a length of 20. And then I do the same thing for the yellow, and that should get all the objects it hits. So this won't, it's a sphere cast all. All means it's going to return all the objects it hits. So that's why I have to have a ray cast hit array. Now I'm just going to cast through all the hits that I got in the hit white. And if one of them is the barrier white, when I ray cast off in this direction, then barrier white, I'm going to set is white to true. And then I go the same thing for the hits in the yellow side to see if anything I hit is yellow. So if it is, then it's true. So I'll declare that I'm going in the right direction if at least one of these ray casts or both of them are hitting the barrier white, the barrier yellow. Okay, so is white or is yellow is true, then is right direction is true. So that's my first observation I add to my neural network if I'm going in the right direction. If I'm going in the right direction, I'm going to add a reward to encourage the car to keep driving in the right direction. And I don't need this anymore. Then over here, sensor add observation is white and is yellow, just to see, just some more information there that, if the is white is true and the is yellow is true. I just give it more information. Maybe I don't even need those, but I do need the is right direction one. And that's how I added the extra observations to the car. Remember, you don't see them here because this is the raycast, the ray perception sensor 3D, which draws the on-draw gizmos for that. But when I did my collect observations raycast, I don't have any on-draw gizmo to show it in the scene, so it's just I just know it's happening. All right, so with these things there on all the cars, and me fixing the fact that I forgot to set the car tag and the layer perception layer, I did the training again. So let's see here for the training. Here's the right direction. I set it to a very, very small reward value. So I did the training and I trained a flat brain right here, and this is the results of the track driving around. So you can see that the cars aren't hitting each other as much anymore since they could see where they are. That was missing from the last one. And as they're coming around the track, if they get confused, they go the right direction better. And I have a pretty good, driving situation here, I feel. Yep, and if they get on the gravel or the barrier, they go much slower. It's much more sticky to ground. So they're always trying to stay in the middle to get the highest speed. And this guy is in last place. Okay, so now probably one of the last things I want to do is show you how you could change your config settings when you run the MLAgents library. Instead of using the default settings, you could actually create your own settings. Like, for example, did I do that here? Let's see, this last training I did went for 1,100,000 steps instead of just 500,000. And you can see here when it started running this training, that's how the max steps were set. And also my hidden units and number of layers, I changed those to a custom value there in the network settings and over here in the network settings too. So how did I do that? That's what I'm going to show you in this video. And the reason why you may want to do something like that is because with the training going on for longer, if you have more experiences you feed to the brain, sometimes the brain can learn a little bit better. And these cars here, if you look back to the way they were before, now you look at how they are now, these are the cars running when I trained it longer, and the reward values got higher. You can see the difference. Now I know the first version of this brain where I didn't train as long, when I let the cars drive around, a lot of them were getting caught up in the corner. A lot of them were just getting stuck in the corner in a traffic jam. And now you can see, let me just go to scene view here. Now they're getting caught up in a corner over here. So they still get caught up in a corner. But sometimes, you get better results. Look at these guys. It's a traffic jam. Nobody's moving out of the way for anybody. Oh, somebody broke free. Okay, they're finding a way to break out. Good. But they're moving around a little bit better. And that's due to the fact that I guess the rewards. So here was a 50,000 is 111. And it got to go up a little bit further. So you never know. Sometimes you train longer and you get a better trained brain. Just depends. So, all right, how did I do this? Well, I had to make my own config file here. And since these cars, the behavior parameter component, I named it Cityblock. I made my own config file. It's a cityblock.yaml file. And in the config file, this is what's in there. It's just some of the settings that I'm overriding, the ones that I want. And the ones that I'm not overriding, I don't even mention them and it'll use the defaults. So you can see here there was like a lot of other default settings. I didn't have to specify everything. I just specified the things I wanted to override. And I found an example YAML file from the MLAgent library install code. So that you could do. You just have to go to wherever you put your MLAgent install. And mine was here in Unity Assets. And here I put my MLAgents release 16. And I just searched for YAML files. And in there, there's a bunch of YAML files from their examples. And there's a basic YAML file that you could look at. And that's how I got the basic structure of the YAML file, like what to type into it. Except you see mine here, I just have it with the things that I needed. So that's why I knew I had to say behaviors and Cityblock. Over here, this one was basic and basic. So I determined that the name of the YAML file and the name right here, they kind of have to match the behavior parameter. So here in the cars, the behavior parameter behavior name is Cityblock. So in my YAML, I named the YAML Cityblock, and right here I named it Cityblock, spelled the same. And then the command that I type to start up the training, it's a little bit different. Okay, you can see here, this is the command I did to start the training. I still say MLAgents-learn, but then after that, I put a space, and then I specify the YAML file, cityblock.yaml, and then I use the force option. So remember, since my environment was already set to the assets folder as a path, and my YAML file is in that path, I don't have to put the path of the YAML file. And that's how I get the change parameters to whatever I want from the defaults.